Good day, guys. Today we will be walking over some of the things. Oh, you guys could hear the music here, but what we are looking at, we're just trying to look at the Comm1140 questions. Not questions, but what they're talking about. They said that we should be preparing for something like this. Section 1 is content of 1 and 3. So what I have out is basically a short 2-minute plan of basically the order that we're gonna do the shit in. So section 1 is multiple choice questions, and they said to complete the weekly quizzes. So we'll start further down the line on the day by finding the weekly quiz, finishing it, right? Then section 2 is financial statement preparation, covering content of week 1 and 3. So once again, they said additional questions tutorials should also be completed. So for section 2, there's a practice final exam question. That's one. And then we'll go to tutorial material for week 1 and 3. For section 3, that's financial statement analysis. So we're gonna do, wait one sec. Is she all that you want? Is she all that you need? I'd be there in a hurry. Baby, come back to me. I can build us a house down across the sea. Okay, so financial statement analysis is right here, right? So that's a practice final exam question. And then once again, that's week 4 tutorial. Week 4 tutorial questions. Week 4 tutorial questions plus additional questions. Then we'll do section 4, which is business taxation. Okay, so it does look like for some reason week 5 and week 7 are somewhere. Oh, never mind. Section 5, valuation free cash flow, is week 5 and week 7. So business taxation is there a business taxation question? Let's see what it looks like. Tax liability income. Okay, so it's a calculation one, and then maybe 3 things about that what we learned, which is about like equity, simplicity, and I don't know, equality. I don't remember. Equity, reduce the gap between the rich and the poor and the poor. Tax the rich a little bit more. Why is it just not working? One sec. Is she all that you want? Is she all that you need? Be there in a hurry. Baby, come back to me. I can build us a house down across the sea. I don't know where it is. Okay. I'll just turn this off for now. Oh, I see it. Am I dumb? There's my second charger. Second USB-C. No. Okay, now it's charging. Good. Okay, what we're gonna... Right. So tax, there's going to be a tax, business taxation, basically practice final exam question, and then week 8 tutorial questions plus additional questions. Once again, there's always an order, as long as we finish all of it. Then we'll be looking at Section 5, Valuation and Free Cash Flow Estimation. So that's Section 5. And then what we're going to be doing in that section is Valuation and Free FCF, Practice, Final Exam Question with the week 5 and 7 tutorial questions plus additional questions. Then we have another one, which is week 9 audit and internal control. And internal control used to we're going to do that together with the additional practice questions. Okay. After that, there are 3 attempts for the final exam. So I think we'll do our first attempt Comm1140 T2 2026 exam. And then we'll basically revise from there and see how it goes. Fuck all the lecture material. Yeah, I don't think that's accessible, basically. Stakeholders, CR. Non-financial reporting. This is just their way of definitely not learning this. Revision workshop might be an important one. Week 11. 11. Is that a day that we'd like to... Okay, so there's a 11 a.m. to 1 p.m. workshop that we could kind of watch. Pencils, pens, ID, MFA. Is there anything else that we kind of want before we just shut this off and continue studying for our paper? Sample questions. I need to see what the weekly quizzes look like. Weekly quizzes. Never seen that before. Let's look into week 1. Or are they talking about like quiz being in the lecture material? Maybe your not really test your understanding. Let's see. Is there a quiz anywhere? where the fuck does the quiz look like? I don't. Huh? Okay, let me see if I can find something in the textbook for Comm1140 before we start. Inventory. Reporting. Okay, there are some practice problems that maybe we can look at. And I don't think we did that. Quiz. Quiz. Tuesday, 11th from 2 p.m. Perfect. That's the day I should be asking my tutor what to do. 2 to 4 p.m. So it looks like that 11th just becomes a Comm1140 day. 1, 2, 3, 4, 5, 6, 7. No, basically, yeah. Holy shit. We are getting close to exam season. Is she all that you want? Is she all that you need? I'll be there in a hurry. Baby, come back to me. I don't see the fucking quiz. Show me the MCQs. MCQs. Weekly quiz questions. 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 I saw survival guide somewhere. Huh? Weekly quiz. Weekly quiz questions on Moodle. Weekly quiz questions. Weekly quiz questions. Attempt the weekly quiz to get feedback on your understanding of key content. Oh. Oh my god. There's a lot. Okay. We have found the mothership. We have found... That is so hidden. Okay. 18 of these questions, weekly quizzes. Okay. That would mean instead of doing the MCQ together, we should do the quiz before each section, eh? Yeah. So we just do like week 1 to 3 quizzes with notes or something. And then this is week 4 quiz with notes. This is week 8 quiz with notes. This is week 5 to 7 with notes. And then we go through the questions and then we attempt the final paper. Is there anything I have to... Is there anything I have not done? Okay, okay. Okay, let's watch the final algebra lecture for today. And then we'll do this homework tomorrow. Oh, let's do this tomorrow. Yeah, 3 questions to solve for the Comm1140 homework. Down across the sea, I'll be there in a hurry, baby, come back. Algebra 2020, final lecture, Comm1100 post lecture. Test 3. This is weeks 8 and week 9. And 9. Submit the paper Saturday night. Okay. Okay, let's get started. That was 20 minutes of just getting into the groove. Did I need it? Probably not, but just make sure we have our expectations right. What's this? Mathematics. Beautiful, beautiful questions for mathematics. Right, let's go to our final lecture. And let's just skim through who took the few hours of the first lectures today. Here. Okay.
Good morning, everyone. Can we all
CDF function?
For just referring to
Right. Expected value. Binomial. Is this a Monday? Yeah. Yep. Very theoretical, right? No problems to work through. And then he's gonna go into applications of integration. Okay, cool. That's the next one. All right. That means we will finish out on 1 hour of this. How much is that? 20 minutes, an hour, another 2 hours. It's 8. I'll be able to finish a 2020 paper, a T1 paper. Yeah. And then 2020 T2 tomorrow. Yeah. Okay. Okay. Lectures. Algebra lecture. Calculus 21A, 21B, 22A, 22B. Algebra final lecture. And then when I get tired, I'll do the Comm1140 lecture. Okay. Eshko. Milan Pahor. This was yesterday, isn't it? 10.34? Yeah. Z, right? Z and phi? Yeah, okay. Let's go. Hello, Mr.
Our final topic is the normal approximation to the binomial distribution.
Yep.
And this is a very strange meeting of two very different worlds.
Let's see if my iPad works.
The binomial distribution is definitely discrete.
Okay.
So the typical example,
Yes,
for example, is if you toss a biased coin 1,000 times, and what is the probability of getting exactly 420 heads? But you get either 420 or 419 or 421. You can't get 419 and a half heads. So it's definitely a discrete random variable. And sometimes the questions in the binomial distribution get very heavy because of the size of the number of opportunities that could occur. So for example, say you do toss a coin 1,000 times, you could get no heads, or you could get 1,000 heads, and you could pretty much get any number of heads between those two. Anything is possible. And that sometimes makes the answering of questions quite difficult. The normal distribution, however, as we've seen, is most definitely continuous. It's most definitely a continuous random variable. And it's a little bit surprising that these theories actually meet somewhere, that they have the opportunity to meet. But we do have the possibility of using the normal distribution to approximate the binomial distribution. And just to motivate this, let's just have a look at a little example. So we have a biased coin. Probability of heads is 0.8, and we toss the coin 50 times. So there's something wrong with this coin. It comes up heads 80% of the time, it comes up tails 20% of the time. And we repeat that experiment 50 times. And the question I'd like to answer, what is the probability of getting less than or equal to 42 heads? So if I run this experiment, I toss the coin 50 times, what is the probability of getting less than or equal to 42 heads?
Let's see if we remember our maple. Think we start off with defining something as a random variable and then open bracket binomial with the number of times, which is tossing 50 times, and then the success rate here, P, is 0.8. Let's see if we can write it out though. X is some random variable, right? X, I don't remember too much. Down across the sea, I'll be there in a hurry. Maybe like this. See if we can how do we display? It's okay. It's okay. We'll just alt tab here. Oh, you can't alt tab at all. X random variable. Or is it like with statistics? X is some random variable binomial. Don't remember. Maple first year. Binomial. Coefficient. Binomial 4-2. Random. Chat GBT. How do I set up a binomial distribution on Maple? X is some random variable with statistics. Binomial NP? I forgot. Right? X is given by a binomial. Oh, okay. Perfect. A binomial distribution, right? This is same as the idea that we've had X tilde. I don't have a tilde on my fucking tilde symbol. I don't have a tilde. Fuck you. This is the same as X is distributed normally with NP, right? Same. So imagine X as a function of a random variable binomial. NP is 50 and P is 0.8. Okay, so it's got something like that. Now that function hits, we can use a load of this. We can use all of this skill. New skill. That means mean of X is 40. We've got the probability of X being less than or equal to 42, was it? Oh, sorry, just less than 42. Works the same. Is it not? Why? CDF, PDF. Okay, for anything that is related to less than, we should use CDF, is that right? CDF X 42. Okay. Oh, this is so nice. Okay. PDF X 42. Okay, the PDF function sounds stupid. It should only be the CDF function. Yeah, cumulative. We could do var x. We could do standard deviation x. We could do oh, that's what they're doing. Probability of x being less than or equal to 5. So this is the same as PDF function. Woohoo! So, sorry, 542. Sick. Okay. I will remember that. Instagram.
Now, this should be a fairly large number because we would expect around about 40 heads. So if it's going to come up heads 0.8 at the time and I toss 50 times, 0.8 of 50 is 40, 8/10 of 50 is 40. So we're kind of expecting around 40 heads. So getting less than or equal to 42 heads would not be a surprising result. In some sense, it's what we expect.
Yeah.
But if we're actually going to calculate this probability, we are up for a big job. Because here is the chance of getting 42 heads. There's your 42 heads. There's your 8 tails. And there is your choice of the position of the 42 heads from the 50 positions.
Yeah, I agree.
And we start working, don't we? So there's your 41 heads, 9 tails, mixed, 40 heads, 10 tails, mixed, all the way down to ultimately no heads.
But you would just write out like the 50 combinations and then you'd write, oh no, actually no, because this is not a half. This is an ugly 0.8 to 0.2. So it's an unbiased distribution. That's right, unbiased it's a biased probability, so it's really hard to find.
50 tails all mixed up. A huge calculation. So even with a computer, that would take a little bit of programming. So quite a huge number to calculate. Now you may think, well, I'll flip it around the other way. So rather than finding less than or equal to 42 heads, I'll go for the complement, which is bigger than 42 heads. But even that involves 8 calculations. So even if you go for the complement, it's still a huge calculation to make. If I change this 50 to a 5,000, well, then you're in really big trouble. So there'll be thousands and thousands of calculations that you need to make. Now, just remember from the binomial distribution lecture that in this circumstance, the expected value and the variance is relatively simple to calculate. The expected value, intuitively, we know is NP. So we have a 0.8 chance, and we're doing it 50 times. So we've got expected value of 40. We expect 40 heads here, which makes a lot of sense. And we saw in the previous lecture that the variance, this is not so obvious, is NPQ. So NPQ, and that's 8. So that's the first thing to observe here, that although the actual calculations are quite heavy, the calculation of the expected value for this scenario and the variance for this experiment are not difficult. So we know what E of x is and we know what V of x is. Now, what we're going to do is take a continuous normal random variable with the same mean and the same variance. So we're going to lift that mean and variance and put it across to a continuous normal random variable. Now, if we just draw these two, we see something quite remarkable. So this is a simultaneous sketch of both the discrete random variable together with this continuous random variable.
I don't know why
Now,
they
on
would
the
need to
discrete
do
case,
too
you can
much
see
about it.
that the discrete random variable maxes out at 40 because that's
But what they're saying is this is without the use of maple, and if we could kind of approximate, then we have y is some 42, and then you do the same thing that you do, right? Y minus 40 divided on 2 root 3. Sorry, 2 root 2. Yeah. And then you'd get your similar levels. Would we want to do that though?
the most likely outcome. As you go away from 40, it quickly drifts down to 0, as you would expect. So, for example, the probability of getting no heads is minute, as you would expect. Seeing as you have a 0.8 chance of getting a head on any throw, the probability of getting no heads in 50 throws, although finite and non-zero, is very, very small.
Yep.
So you can see that the binomial probabilities drop down from the center, as does the normal distribution. The normal distribution for N48 also peaks at 40 and drops down to 0 on the two wings. And what you can see is that they're almost the same. So the actual structure of the decay for the binomial and the structure of the decay for the normal are perfectly matched, provided, of course, you choose the appropriate mean and the appropriate variance. Now, what that means is if you really want these probabilities, maybe rather than dealing with the binomial, it would be easier instead to deal with the continuous random variable in its normal shape. Because what might take 50 calculations using binomial distributions may only be one calculation using the normal random variable. And indeed, that's exactly what we will see here. Now, before we have a look at exactly how we're going to pull this off, there is a technicality that I just want to isolate for a second. I want to use this connection to simply calculate the probability that x equals 42. So I'm going to try to calculate the probability that x equals 42. Now, on the one hand, we've done it up here, haven't we? So there's the probability that x equals 42. We've got 42 heads. We've got 8 tails. We need...
And you need a coefficient of 50 choose 42.
To choose the position of the 42 heads from the 50 tosses, and that is 50 choose
That should be
42.
0.1 something, eh? Okay, let's see. Yes. P x 42 is given by 50 choose 42 times 0.8 times 0.8 to the 42 times 0.2 to the 8, with py is 42 given by y is a normally distributed function at, was it 50 with variance 8, 40 with variance 8, y py equals minus 40 over 2 root 2 is equal to 2 over 2 root 2 is the probability of z being equal to um, down across the sea. Eval Scroot 8. 2.828, okay? 2.8284. Alright, so we go to our table now. 2.8012. 0.9976. 0.9976? No, we have to take 2 divided by this, right? Yeah, 2 divided by square root 8. I forgot. 0.7. I'm trying my best not to look at the 7071. I can build us a house down across the sea. 7.7 7. It's closer to 7.1. So I'm gonna take this number. 0.7611. Sorry. We have to. This is. How do I do this? It's equal. What is the. So I can't use this table. I have to use the normal. Do we have the normal table? It's not a phi question. It's an equals question. So how do you get an equals out of this? Phi 0.88 minus 0.753. What does that give? Why? Is that 43 and 42? 41? Is this... Maybe that's how they want me to interpret it? Maybe? That's my assumption. So we're going to follow our assumption. I love you, Christine. I provide hope core. So this is z is less than or equal to 3 over 2 root 3, 2 minus pi z 1 over 2 root 2. Let's see if the numbers match, and if it does, we're cooking. So 3 is 1.06. That's not right. Where the fuck is he getting these numbers?
So that's the probability, because it should go up to
41.5 and 42.5. Oh. Why?
42.5, and it should also go down to 41.5. And this is quite important, because what this means is that any individual value is picked up by simply looking a half a unit to the left and a half.
You're right. I'm dumb. This is way too big. He says that this at 42, and if you do 43 and 41, then you're picking up 1 unit already, which means the distance here is 2 units, is too much. Too much. If we instead we do P is y is equal to 42 and a half minus y is less than or equal to 41 and a half. You're going to get a much better one. You're going to get a... My god, my lamp power, bro. You're going to get a 0.5 here, right? And a 41.5. So you're actually going to get a distance of 1 here. Then we have 2.5 is 5 on 2 on square root 8. sorry, z minus pi z 3 on 2 on square root 8. Which now should be correct because okay, 0.53. Oh, so much better. Which should evaluate to this one. And then also if we evaluate, we should always evaluate z to be a function of a random with statistics. And once again, with the statistics package. Oh my god, I should be teaching mathematics. No, not teaching, but I need to make some money off tutoring. I can cook these kids. I should search up their requirements for transfer. Down across the sea. My goal for the next term or this term is to apply to try to get some tutor hours because I make 60 an hour. I'm okay with that. I'll be happy. Yes, ma'am. With statistics, and thank God I'm filming this shit so I don't forget. You know, all I need is like a 10-hour lesson, a 10-hour grind for my students, and then they could just pick up HDs across. Let's see, with statistics, we're doing Z is some random variable. Sorry. Random variable. Open bracket normal with variance with mean is 40, variance is 8. Right? Then we have probability Z is equal to 42. What? Nope. Nope. Maybe it's just a... No. I'm being gay again. I'll just use this one. PDF X 42 0. Yeah, okay. I don't know what that means. I don't know what that means. Cumulative. I don't know what Dirac means. But that's the right number. Also, binomial PDF at P is X equals 42 gives 0.11692, which is equal to everything here. Okay, good.
To the right. In other words, all of this area, in some sense, corresponds to the value at 42. And that's the price that you kind of pay.
Oh, okay. So with binomial... Okay. Oh, I'm a dumbass. Come on, Jaden. Jesus Christ. Be smarter than that. They've given us this. So Z is some normal at 40 evaluate for 9. And then to estimate B, sorry, X is binomial at 50 and 0.8. Wait, how they get 8 and 0.8? Wait, how'd you get that number? Oh. Oh my god. So here, okay, I've got it. Let's get another page up. This is X is binomial NP, right? Which implies X is some binomial with a 50 shots, 50 flips, 0.8 success. Boom. Then to estimate mean of X is equal to NP is equal to 40. Variance X is equal to NPQ, which is 50 times 1, fucking a fifth times 4/5. Let's do it this way, because then you get 8. Then let Z be a function, no, Y be a function of normal with 40. So I'll just write mu here and variance here. 40 and root 8. 8. Then we can estimate X's probability of X being 42 by, then we can have our image at 42 right here. And then we'd have 42.5 and 41.5, 0.5, 0.5. Yep. So that is 1, which is equal to the probability of 41.5 y 42.5, which is equal to phi of 42.5. No, which is equal to 3 on 2 on 40. Fuck. 41.5 minus mean over standard deviation of Z is 42.5 minus mu over standard deviation, which is equal to these numbers: 0.88, 0.53, Z, 0.88. So let's see if that works here, right? We have our binomial distribution, and that's the PDF. We also have a y, which is a random variable of normal given at 40 and 8. And if I can find the probability 41.5 y 42.5, Really? What happened? What do you mean? Like that, maybe? How could I do it for normal? And also evaluating at a specific point. So like, instead of p of x at 42, I evaluate some y at as a normal distribution at 41.5 y 42.5. Mu sigma, yep. Eval probability. What the fuck? Are you serious? Huh. Probability. Ohm bracket. I have to use and. I have to use and. Okay, I could do that. Which is better? Is it 50 or 40? That's the wrong number. Does that mean I should just do Z is 0, 1? The hell? CDF. Z at 0.88. CDF Z at 0.53. What's going on? It's not the probability density function, is it? No, no way it's not. It's not that close. Choose it to be near
When you
you.
make the trip from continuous to discrete. So that's what we have to do when we actually make that jump. We know that that will cause difficulties. We know that that will give us a zero answer. So instead, we just shift a little bit to the left, a little bit to the right, half a unit to the left, half a unit to the right. 42 is essentially responsible for everything from 41.5 to 42.5.
8-1 or 8-8?
41.3, for example, will belong to
No.
41, not to 42. Now, this is now a range, isn't it? We can actually find this probability using our theory from the previous section.
Mm.
And all we then have to do is subtract the mean, divide by the standard deviation. So we subtract 40 and divide by root 8, keeping in mind that the variance is 8, isn't it? The variance is 8, so the standard deviation is root 8.
Is the normal distribution usually taking in sigma or sigma squared? That might be fucking up with my answer. Maple's command takes the standard deviation. So I have to take the square root. Maple's command takes the standard deviation for normal. So mean of binomial of a mean EX is equal to n times P is equal to 40. Variance is 8. But Maple takes square root 8. Okay, then we define y as a normal with 40 being the mean and the square root 8 being our actual sigma. R3. Fine. Then we have CDF of y less than 42.5 minus CDF of y less than, sorry, not just like this, 41.5. Okay, now we have a little bit of a better approximation. But it's not close. It's not close. Approximation is a little bit closer.
This gives us the probability that Z is between 0.53 and 0.88. Now, in terms of a picture, suddenly we're in familiar territory. We have the standard variable T2 is less than or equal to 42.5. Now, this slide from 40.
Why do they do this? Why do they correct to 42.5 rather than 42?
42 to 42.5 causes a lot of confusion for students. But remember that 42 essentially runs between 42.5 and 40.
But that's what we did. So this means like P of X, P of X is 42 is equal.
.5. So 42 does have a region of influence, a half a unit to the right and a half a unit to the left, and that has to be respected. So everything between 42 and 42.5 belongs to 42. Now, when you do this trick, this just little correction, and some people don't do this, but it's a good idea to do it because it is a more accurate answer. You should always be adding a little bit of area. So sometimes students wonder, well, how come why didn't I get a 41.5 here? And the reason is I wanted to make sure that everything that belonged to 42 was taken into consideration.
Yes, I agree. That's like when you draw this, let's just draw 40, sorry. Right? And this is 43, 42. And if we want to take everything from up to 42, this is like we want to be blocking it up so that we can make it 40. So 42 is essentially the same as 41.5 to 42.5. So that's, we make that the 42 block.
So you always end up just going a little bit further than you needed to go. You need to include a little bit of extra area. Now, this is a simple calculation to make now, isn't it? So instead of the 42 calculations that I need to make over here, all I need over here is 1. I subtract the mean, I divide by the standard deviation, I subtract the mean, I divide by the standard deviation. This now becomes the probability that Z is less than or equal to 0.88. And that's just directly calculate a word 2.5 divided by root 8. And this is phi
0.88,
of 0.88,
which is seen
which of
directly from
course
the
from your
table.
table
Very,
is
very interesting.
0.8106. And there is that whole calculation done in one go. Is it exact? No, it's not exact, but it's pretty good. So it does a pretty good job, and it saves you an immense amount of work. And this is when we tend to use the normal approximation. When we're sitting there staring at hundreds and hundreds of binomial calculations, and we know that instead we can do just one normal calculation. Now, we've discussed this in a fair bit of detail. So why do we use 42.5 rather than 42? And essentially it's because 42 is in charge of everything from 41.5 up to 42.5. And that's in some sense a glitch that occurs because of the transition from discrete to continuous. That's how we accommodate that move. Now, just a small point here as well, that we only ever do this little correction, this little half unit
When we're
correction,
asked
when
to.
we're using the normal approximation to approximate
Yeah.
the binomial. If all you have is a normal question, you don't play these sorts of games. So if you just have a normal probability that you're trying to calculate, and we ask you for the probability that a random variable is less than or equal to 18, you definitely do not go to 18.5 if there's no binomial probability loitering in the background.
What? What happened to rent? One sec. Invoice. 102. Hi. The money shall hit the correct. So much money, bro. Ugh. So much money.
You need to be approximating the binomial to do this. Okay, so let's have a look, just a little summary, because a lot happened there. We have a discrete random variable x following a binomial distribution, n trials, probability of success of p, probability of failure of q, where that's 1 minus p, of course. Then x can be approximated by the continuous random variable y. The mean of your normal distribution is NP. The variance of your normal distribution is NPQ.
Yeah.
Let's have a look at another example. These are quite interesting. So suppose we have
We would suppose there are 2,000 digits, so that's n is 2,000. From a set of 10 digits, the probability that a digit 7 appears less than or equal to 190 times. We would expect well, there's 10 digits, so if it's unbiased, the probability of each digit appearing is 0.1, right? And then that's p 0.1 for our variable, for our x random variable 7. But we would need to sum up 190 binomial probabilities. We would let x count the number of occurrences of a 7 in a 2,000 digits and move to a normal approximation. Right. So the new expected is 200 with the variance of 180. And then they would do y is less than or equal to 190.5, which is equal to whichever that is. Okay, cool.
1,000 digits, randomly selected from a set of 10 digits 0 through 9. So we just have a string of 2,000 digits, randomly chosen from 0 through 9. Find the probability that the digit 7 appears less than or equal to 190 times. Quite a tricky little question. How many times would you expect it to appear? Well, I would expect it to appear 200 times. So a tenth of 2,200. So you're expecting it to appear 200 times, but possibly it won't appear at all. And possibly all 2,000 digits will be 7. Anything can happen. Now, no matter which way we go, even if we go direct or if we go complement, we're up for either 200 calculations or 800 calculations. So there's an enormous amount of effort here to figure this out exactly.
Sorry.
So our expectation here is NP. So what do we have here? We have N equal to 2,000, and we have P equal to a tenth, and we have Q, of course, equal to 9/10. So the probability of success here is a tenth. So there is the data that we need. So where do we stand? The expected value is 2,000 times a tenth, NP, which is 200. You don't really need a formula for that. That makes a lot of sense. You'd expect to see 200 sevens. Variance, a little bit less obvious, NPQ, which is 180. So the appropriate normal distribution to use is this one, NP, NPQ, mean of NP, variance of NPQ. What do we wish to calculate? We wish to calculate, what do we wish to calculate? We wish to calculate the probability to calculate 190 binomial coefficients, and that'll take you 10 hours. So it really is quite a significant advantage in terms of the amount of labor that's involved. Keep in mind, it's not exact. It's good, but it's not exact. Okay, let's have a look at example 7. So I think this might be our last example. Indeed it is. So in a certain Scandinavian country, every purchased car is either a Volvo or a Saab. Historically, Volvos dominate sales with 70% of the market share.
The Saab company runs an advertising campaign to increase its market share from 30%. The advertising campaign, a random survey of 300 sales, was conducted and found that 111 were Saabs instead of the expected 90. At a significance level, 5% determine whether or not these survey results 30% of, okay, let's do this question. Actually, they've done the question. It's okay if we can basically understand it. You have that is N is 300 sales. You've got the expected value here, right? Which is EX is equal to 0.3. So that's the success rate. Yep. 300 times is 90. So let X be defined as binomial 300 and a third. 111 were found. Begin by assuming that the campaign had no impact. Let the discrete random variable X count the number of sats sold in 300 purchases. And then you'd find this, and variance is this, and you could approximate. Well, they want a 5% significance whether or not the survey results was successful. So is 111 inside the 5%? Is 111 inside? the top 5%. This is 0.5%. So the sales have improved. Okay.
That is that it's still true that subs have 30% of car sales. A random variable, so we minus half 5%. We've had to have assessments 0.5% instead of 5%. Any little error here could easily be forgiven. Okay, that I think is our last example. So that brings us to the end of proceedings. Just a few final points to make, just in preparation for your exams. Please make sure that all your marks are correctly recorded. So make sure that the data that we have for you is correct. Make sure you read everything about additional assessment, special consideration, just so that you're fully aware of the rules that apply. These rules constantly seem to be changing, so make sure that you're aware of exactly what you need to do, what documentation you need. There should be plenty of past papers on Moodle for you. And make sure that you're fully aware of exactly what sort of paper you're sitting and when that paper is on. And if you have any doubts about that, either go to the Moodle page or have a chat with the first year office. There'll be plenty of surprisingly deep. So mathematics, I think. It's very direct, it's very simple, and the results are surprisingly deep. So many of the objects that pure mathematicians look at, vector spaces, Banach spaces, C-star algebras, Hilbert spaces, all of them begin as vector spaces. So it's in some sense the first step towards pure mathematics, this abstract linear algebra. Let me wish you all the best in the future and in your final exams. And please remember that there is help available over the next few weeks.
Nice. Thanks, Mr. Milan. Let's check. Let's finish some of the core papers that we've been given. Now that we know how to solve these. Okay, let's do this question. Down across the sea. Okay. I'll be then, hurry, baby, come back to me. I can build us a house down across the sea. Tell you I'm sorry, baby, come back to me. $31. Okay. Let's do this. Alessandro and Hannah are doing mathematics. One loves probabilities and defines the random variables x and y. X follows a normal distribution with a mean of 3 and a standard deviation of 2. Y follows a binomial distribution of 17 and probability of 0.61. Calculate the probability that X is less than 3.1. You can use Maple code. Yes. So they do give you Maple code. Right. Okay, X is a random variable. No, with statistics. X is defined as a random variable such that we've got a mean of 3 and a standard deviation of 2. Yes. So Maple uses SD equals 2. Be very careful. Sorry, random variable normal open bracket probability, sorry, eval probability X less than 3.1, is it? Okay. Okay. We're good. First question down. 0.5199388 da da da. Hannah's favorite part of mathematics comes from geometry and thinks it's a good idea to mix geometry and probability. Let R be the point on the plane with coordinates x, y. What's the probability that the point R lies on the horizontal line with the equation y is 14? Equation y is 14 means we've got 14 right here, and then it just runs across. Probability that point R lies on the horizontal line, so that means the distance here, y is equal to 14. So they're asking binomial distribution, y is 14. And anyone is fine. Yeah. It's the same as y is equal to 14. So I think we could still use binomial distribution. We'll evaluate some y here with a binomial, and we have a number, n is 17 and p is 0.61. Then we have evaluate probability that y is equal to 14, 0.3. That is correct as well. 0.03984. Find Hannah. Sorry, here you go. Hannah draws a figure with 4 points. I don't, okay. 3.1, Okay. Sure, I'll just draw it on here. A is 3.1. 14.7. 4.5. 14.7. Right, so it's on that same line. And then you've got C is 4.5. 12.8. 3.1. 12.8. Okay. Find the probability that the point R, which is um R is anything on the map. Boom. R is anything on the map. And XY means X chord time probably of X being something times probably of Y being something, maybe. Find the probability that point R is to the right of the vertical line AD. Is to the right of vertical line AD. So AD has X is 3.1. So probability that X is larger than 3.1. Which is same as 1 minus the probability of X being less than 3.1. Which is equal to, let's pull up our guy here. 1 minus, eval probability of X being less than whatever. That's our answer. I won't look at the correct or not. So I'll just put it there first. So I'm going to write this as 0.480611. What's the probability that R lies on the right of the vertical line? If it is known that it lies to the left of the vertical line. So probability of X being larger than 3.1 if it is known. So is this a given question? No, it's probably not conditional probability. It's probably just your normal 3.1 X 4.5, which is equal to CDF X 4.5 minus CDF X 3.1. Okay. So we'll go back. Eval CDF X 4.5 minus CDF X 3.1. What's the probability that R lies on the right of the vertical line AD and above CD? Fuck. Now I'm getting kind of... Okay, so it's a given. It's a conditional probability. So the probability that x is between here, given that it lies on the left probability of x being less than 4.5. So I'm going to have that, and I'm going to have that divided by that to give me that, which is correct. Nice. Equal to 0.25343 divided by 0.7733, which is equal to 0.32769955153. Okay. What is the probability that it lies on the right of the vertical line AD, which is larger? Times probability that, is it time? Think. Right of vertical line AD and lies above. Is it the same probability? Above CD is above 12.8. Y is above 12.8 over PY above 12.8. No, it doesn't. Could I try it? Oh, it's right. Nice. Which is the same as 0.480061. Okay. And what's the probability that R lies between the horizontal lines AB and CD? Which is probability that X is between what? 3.1 and 4.5. 3.1 X 4.5. Which is equal to CDF X 4.5 minus CDF X 3.1, which is this number. Oh, lies between AB and CD, horizontal. So it's Y. 4.7 and 12.8. Right, 4, 14.7, and 12.8. Could I do it? CDF of Y less than 14.7. So binomial CDF minus binomial CDF of Y is 12.8. CDF of Y. So this is the, yeah, CDF of Y, 14.7. Okay, so that's the actual number, minus CDF of Y being 12.8. That should be our answer. Nice! 0.128994. 0.128994. Okay. Alessandro's turn to mix geometry and probability. Alexandro is admiring Hannah's work and decides to do the same but with different random variables. He defines two new random variables which he denotes x prime, y prime, independent from each other. Just like Alexandro did, he defines a point r prime to the point of the plane with x prime, y prime, then calculate the following probabilities. Okay, so they're giving me some number and they want me to find alpha. Never mind. Horizontal lines. So y, right? Yeah, y. So, sorry, y prime. Probability of y prime being between AB and CD is that last question we just did, 12.8. P 12.8 y prime 14.7 0.263 and r prime p x 80 vertical lines, AD and BC, so 3.1 and 4.5, p of 3.1 x prime 4.5. What is the probability that the point R lies inside the rectangle shown? Rectangle ABD. Rectangle. That's the rectangle, eh? Okay, so this is and or, right? and an or. Basically an and an or question. And question. P px and py question. Yellow course is a px or py question. I think we just add both of it together. This number times this number, and then this number add this number. Okay, well, first one is right. Second one lies inside the yellow cross. Lies inside the yellow cross. Lies inside the yellow cross means that R prime has to be in between DC, AB, or in between AB, DC, or both. Could we use a tree diagram? We could use a tree diagram. Dead ass. Yeah. R prime. Inside rectangle. No. Between horizontal. We'll do horizontal. No, ugly. I think it's this plus this plus this. Or minus that. Minus this. Okay, right. So, okay. It's an and. Okay, it is a. So this is like a P A. This is like a. Which is equal to P A plus P B minus P A and B. So it's equal to 263 plus 0.7 minus this 0.263 yen. Nice. Nice. Wasn't so hard. Okay. Next question. Whenever you are asked to calculate the probability to enter it as a decimal correct to at least 4 decimal places, it means that you calculate probability equal to, but then you may enter that or the larger one, but not that. Too few decimal places, not wrong rounding, and not 19. Okay, so we could spam the shit out of binomial and normal and not care about anything else. don't know why people wouldn't be using binomial here. Ooh, quantile's a cool one. Quantile. Wow, đồ ăn thơm quá. A Rome malicious tea company produces packets of tea which are supposed to contain 695 grams. Is this there's another question after it. Yeah. It is found that the packing machine delivers an amount of tea which is approximately normally distributed with the mean mu grams and standard deviation 9 grams. Here the mean mu can be adjusted by turning a dial on the machine, but the standard deviation cannot be changed. To allow for margin of error, the operator sets a 7. Oh, that's way too much. Okay, so it's normally distributed. And we've got, let's do x is normally distributed with a mu of 709 right here. And sorry, I'll do this first. Mu lambda squared. We have x is this with this and standard deviation of 9 grams. So 9 squared. To allow for a margin of error, the machine operator, okay, the proportion of packets under 600. So x being less than 695 is the same as normal CDF x695. But maple, we need to make sure that we have x is random variable normal with mu and just that. Okay, let's go. New page. You start, define x as a with statistics. X being random variable normal with a 709 and a standard deviation of 9. Then we want to calculate the CDF of, also this question, I won't check right or wrong. I'll just make sure that we can do shit blind. Earth, that's not good. I don't like to see Earth. We'll do probability. Earth. Maybe eval. Here you go. Found. First number. In order to make the proportion of underweight packages at most 43 per 10,000, what should setting be used for mu? Okay, so now that they've given us 43 over 10,000, they've given us a 0.00043. Is that right? Just to make sure my math is not wrong. 0. Just 2. What setting should be used for mu? And enter your mu. This will be used to award partial marks if your answer to B is wrong. Should the continuity correction be used in this question? Explain or why. Continuity correction. What's continuity correction? Okay. So x is normally distributed at some mu for, we have x of some mu. Now we've given 9 squared, and p of x less than 695. So considered this whole thing. Ew. Ew. Okay. Considered underweight is equal to 0.0043. Could we solve x like this? What's quantile? Value of q from x. Quantile known area. Value q. Q is what? 695. Quantile maple meaning. Pth quantile. I don't care about q. I already know q, eh? Oh, I guess if we have... We'll find quantile then. Could I just write like solve x? Solve open bracket x. Oh, we'll use like small x. We'll use small x. How do you do this? Yeah. Okay. We'll solve x. No, we'll solve an expression for x. Yeah. What expression are we trying to solve? We're trying to solve that big X, sorry, the probability, yeah, probability of big S being less than 695 is 0.043. F solve? No. Wait. This eval is here. And you've got another X there. See if they can evaluate that. I don't see the importance of quantile right here. Fine. I'll see what it looks like. 709. Sorry, not restart. Quantile X with a known area of 0.043 gives me 693. Oh, that's the shift, eh? That's the shift from our mean. That's the shift from our mean. That's our quantile X at 0.043 gives me a mu of an EX or a mu of 693.548. Now I have a mean and a mu, and I need to solve for the old mu. Right? I knew. Mu is equal to 709, gave me a and now I have mu is something. P of x less than 6. No, I don't know how to I don't know how to solve it. Yo, chat. I've given you the information you needed. I have Maple to use. I know that I need to find the old mu, and I know that the probability that x is less than our 695, so the probability considered underweight is 0.043. But how could I use Maple to basically solve for my initial mu so that I can set a mu that hits exactly 43 out of 1,000? I was also given the function quantile, but when I find the function quantile, I just see that it's used as a way to find that specific quantity. Could we somehow use something related to the equations of like Yeah, could we use something related to the expressions of like var x or mean of x to solve, or is there a specific way that I could be thinking about this question? Because I would assume that there would be like an inverse CDF function that could pinpoint me exactly the initial mu. I want my chips so bad. I'm so excited for tomorrow. It should be expected to come tomorrow. Tuesday, 4th of August. I get my chips tomorrow. Yay! The key correction does yes. Yes, I know that. Where Maple uses standard deviation, you'd want. Okay. Quantile is the exact inverse CDF you were thinking of. Quantile of Z. And mu is that. Oh, that's possible? Okay. Okay, let's try it. I haven't seen the answer, so. Okay. They want me to have some mu Oh, valid. So valid. That set up standardizing equation, you'd have our 695, so target weight, minus our mu over 9, x minus our mu over 9, is equal 0.0043. So our z is less than is equal to 0.043. Then we set the expression as mu target. Let's call it mu t. So find a z with a mu such that it equals no as let's find something else. So this is what we want to find. We want this. This is some z is less than, I don't know, target gamma. I don't know what gamma. No. I don't know. Phi. Fuck. I don't know. Give me alpha. Alpha. Then use quantile. Okay, quantile of z with the because we've standardized it. Use z is a normal function given by mean 1, and then quantile of z. Quantile z alpha. Is that right? Quantile z alpha. Quantile z 0.0043 to get alpha is equal. Oh my god, I'm gonna bust a nut. Sorry. Okay, let's go. With statistics, we are going to set up a z that's random variable, normal. Where's my shit gone? The fuck? Okay, normal 0, 1. Quantile, this z is equal to 0.043, and that should give us our alpha. So alpha is equal to minus 2.6275 of whatever we're trying to find. And so alpha is equal to this, is equal to this. 695 minus mu over 9. Okay, let's find it. Solve for mu. Right, so now we have this number. We're going to solve is equal to that is equal to the expression of 695 minus x over 9. And then we solve for x. X is that. So that's our mu, by the way. Mu is equal to 718.64. Rounding to at least 4 decimal places. So I'll just copy the question. I'll copy the answer over and then tell you guys if it's right or not. Nice. 718.6480284. Explain your method below in part D. Note this will be used to award partial marks. If it's wrong, is there a part where I can basically talk about what I did? Right, so we start with standardize P of x is less than 695 minus mu over 9 is equal to 0.043. Which gives us z is less than or equal some alpha is this, then quantile of z at 0.0043. This is basically an inverse CDF to give me alpha. Then alpha is equal to 695 minus mu over 9. And we solve for mu equals. Right. Should the continuity correction be used in this question? What is continuity correction? Continuity correction meaning? Oh, no. No, because we are not working with normal distribution. With binomial distribution, and so the weight in grams is continuous and doesn't need to be counted using an integer system. I don't know anything else to write. Do I need to explain it in any other way? I don't know how to explain the continuity correction part. Should I just say that it's not a binomial distribution, so it's a range, so it's continuous? I don't know. Using the inverse normal distribution quantile. That's sick, eh? do want that in my iPad notes. No, a continuity correction is used when a continuous distribution, such as is being used to approximate a discrete distribution, such as binomial. Here, pack weight is very mod by continuous, so no continued correction is required. We are not approximating anything related to the binomial distribution. No. Only when we use normal to approximate then using y is n of npq. Okay. Final question. Okay, so we are missing like a fuck ton of questions. Oh, but okay, that might be the... I'm just gonna make sure that we have every single question. This is gonna take about a minute. What the fuck? Ni hao bu hao, zui de 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 Okay, this is a question that we want to do. It is a question 26 based off of surface area and shit like that. Okay, one more question from here, and then a question 26. Let z be a standard normal random variable. Find the probability that z is less than 2.34 given that. Okay. So it must be and then divide. So, okay, so basically that's the same as p of 1.34 z 2.34 over p of z larger than 1.34. Okay, and we can find that. I think we're gonna use maple because it's less bad. Okay. So we have our initial one, and we want to find CDF Z 2.34 minus CDF of Z at 1.34, and then we're gonna have Z, and then we're gonna divide. We are wrong. Oh, it has to be larger, so it's, sorry, 1 minus Z. Yes. Nice. So this is equal to, let's write it in our iPad notes that it's CDF of 2.34, right? So we're evaluating some function. Minus another one of the same one, minus CDF 1.34 over 1 minus CDF of 1.34, which is okay. That gives us a 0.893013937. Okay, what I will do is I will start snipping shit into our thing so that we will have some stuff to work with. Not this. No, where's my quantile question? Is this enough? No. That's the good one. This one we're gonna unsend. And then we're gonna it's a good question. This is a good question. Is this the approximation correction? So that's Maple notes. Sorry, Milan Pahor notes. Okay. Algebra is done. We'll ram on with 2020 questions after I eat dinner. I will screenshot these questions and we'll take a look. So Q26 is the only one, right? Yeah. So Q26 is an arc length or whatever one. So I still have brain power. We're gonna do this one some other time. Nice. Botany. I think by the time I wake up tomorrow, I'll have it. Okay, so we're done with one out of a lot. Fortunately, we get review continually because they source the scene questions from these questions. This looks like a pain in the ass of a question, by the way. So that's like we can just plot it. This is one of the review questions. Ah, shit. Wow, that's a tough question. Oh, why? Weird. No, I think it's the USB file making like a copy. Okay. 2020 T1. End of Q6. Is that it? Ni hao wu hao. Okay, that's it. Okay, see you guys in a bit. 10-15 minutes. Yep. Yep. We're back. We're back. Let's play some music. If we play music, we cannot. Yeah, I can't have the sound, but we will continue to ram on with our 2020 papers. This means we don't need to do any parfrac. I'm still gonna do parfrac, but honestly, with a few maple input commands, we could kind of skip the whole parfrac methods, right? So it's not a squared multiplicity, it's some a over x times plus some b over x squared plus 5 is equal to 5x squared plus 5. But that's also equal to a times x squared plus 5 plus b times x plus 5 divided by x squared plus 5. So plus b x is 5. Let x is 0, a 5a 5a is 1. Let I don't know, x is 1. 5 times 6 plus b equals 5. B equals minus 25. So that should be right. So 1 over x plus minus 25 over Hello.
Hello.
Hi.
这个红脑的人
Sorry, I just texted you back.
有干扰。
Oh, this one? I'm short.
That's it?
Mm-hmm.
Yeah.
What?
Chỉ vậy thôi à.
Là sao? Không phải chỉ vậy thôi đâu. Tại vì Jaden lùn thật nên là trên không có gì để nói, thật mà. Christine thương Jaden thì Christine hãy
Chứ không. It's not funny.
X. The what? X?
Dạ thôi. Cà phê rồi. Bye.
You're gonna leave? How would you decompose it? Why? Why? Why is B not equal to like minus 25 or something? Why is it equal to minus X? Irreducible quadratic factor. It must be... Explain to me what irreducible quadratic factor means. Okay, then what are some of the forms that I need to be able to recognize for fraction decomposition? I know that sometimes there's a situation with multiplicity 2, then there's this situation with an irreducible factor, then there's a normal one. Also, is it that the numerator has to differ by exactly 1 degree or just 1 degree less? Huh? Okay. Integrate. ln times absolute value of x minus open bracket a half ln times absolute value open bracket x squared plus 5. Fuck, I'm a dumbass. Dude, I might as well just like go kill myself because I don't even integrate answer x. 9,000x? Is that not exactly what I wrote? Oh. Okay, fine. There's no absolute values. Why? Is it because... But they didn't define x to be anything. Whatever. Why is there no absolute value around this one? Or, sorry, in the ln. Because when I used absolute value, it was the wrong answer. Oh no. I did it wrong. I'm the one to blame. I'm the one to blame. I'm the one to blame. So when we write it, it's supposed to be ln open bracket absolute open bracket x minus a half times ln. Okay, going back to the original form using the substitution x is root 5 is tan u. We need to write dx is some function of f du. Well, x is root 5 tan u. Dx is, well, tan is sec squared, right? So root 5 sec squared u du. That's our answer. I don't know. Square root 5 times sec u squared. That's how they write it. Yep. Square root 5 times sec u squared. Then we apply the substitution. The integral has the form integral g of u, where gu is. Right. So what happened was... Wait, why am I sitting like this? This feels so unnatural. There's too many wires, too many things on my table. Way too many things on my table. I'm getting kind of overwhelmed with the stuff on my table. I'm a short fuse, you know, when it comes to close to exam season. stress levels, cortisol levels, everything is just fucking crazy high. I can break down any second, I can cry any second, it's a pain in the ass. Alright, we have integral 5x squared plus 5. So they spot this to be an x squared. They spot it to be a tan integral, right? With x squared being x squared and a squared being root 5 squared. Right, so they let x is 10. I don't know why they had to do that, but that's how they do it, right? Du is this, then like that. Ugly ass integral. Oh, this is a nice 8 marker. I mean, firstly, I would simplify it if possible. Now it's a little bit more tame up top. We have 10u times uh 5 10 squared u plus 5, which is 5 secant squared u du over 5 10 cubed u plus 5 10. Okay, we are going to pull out this and make it that. And then we're going to simplify that as well. So we get 10 cubed u plus 1. And then this is, well, 1 plus 10 squared u is secant squared u. So it's basically secant squared u over secant squared tan u du. That's 1 over 10 u du. Could we do it like that? du over tan u. Nice. Well, the integral, well, tan u is the same as sine over cosine, right? So in this case, this is cosine over sine, which if you look by the integral, I mean, you could, we'll just use this one. ln secant x. So I'll just write here by table of integral. Integral of 1 over tan u. Is it 1 over tan u or tan u? Shit. Cosine over sine. It's cosine u times cosec. Ugly, ugly, ugly. Hint, right tan u is sine u over cos u and imply a substitution sine u or u. Could I just write that? A over, no, 1 over ln open bracket sec u. They gave us a hint. That's nice. Okay, we're gonna use cos u, sine u to let sine u t dt is cos u u. You get 1 over dt over u, which is ln t ln sine u. Jeez. Oh, ln sine u is 1 over ln sec u. Oh my god. 1 over ln sec u is the same as 1 over ln 1 over sine u. Ugh, so ugly. Nah, don't even. This is good. This is good enough. Brief here, question. Next question is briefly. So we'll just let this happen here. 1 over tan u. Wait, so what would I don't think Mobius could do this. Or we have to could Mobius convert things to trig? No, like with integration techniques. Oh my god. Hello.
Hello.
Hi, baby.
You can't call me that.
Oh. Hi, Christine.
Chán mày.
Chán không? Ok, miền. Ok, miền. Ok, miền.
You don't feel bored?
No, I feel stressed. I feel stressed. I feel like I could cry any moment. I feel sick, by the way, baby, because I'm sick.
You can't call me that.
Sorry. Integrate.
Bởi vì
Cảm cúm hay sao?
bởi vì
Hả?
bởi vì
Bị cảm. ln x2 ln x squared plus 5 over 2. That looks like something we've done before. Why does that look like that?
ok. Đã gọi xong bye bye.
Từ từ hắn đi.
I just feel so bored. So I called. But I feel like your life seems bored.
More
Also
boring.
boring.
No, I can't do this like this. Maybe integrate
Bye.
1 over 10 u. Don't leave, bruh. U. ln sine u. If I went into this blind, I would need parfrac skills, and then I would need a little bit of literacy on X and Y skills. Could I do like, this is A subs U equals tan inverse, arctan, open bracket x over square root 5. Into A. Into arc 5. Simplify. Answer. Where's my 2? Where's my 2 gone? That does not look like the right answer. This is a pain. This is a bummer. I guess we could just like see which moments we could use maple as a checkpoint. Like this is a parfrac, right? Parfrac. So this is a convert expression parfrac x, you know? And then this one is a int expression x. And then this one is a, I mean, like, could do by hand. And then this one is like this. Maybe simplify this function to see what does maple output at this. So we have convert parfrac is fine, integrate parfrac is fine, gets the job done for the first 2 marks. Then we also have this integral here. I think we'll do like simplify what was given, which is, I mean, we had to go through that. I mean, it wasn't hard, but we would be bound to make a lot of mistakes. So I'm gonna type that one out. 5 times square root 5 times secant u squared. Yep, that's the first one, divided by square root 5 times tan u times open bracket square root 5 tan u squared plus 5. So they do got you. Would that be a satisfactory answer as well? No. 1/10u would be way better. I guess the integration techniques we kind of have to do ourselves. Yeah. It's okay. Have to do ourselves. And then here, once we reach 1/10, we could use maple as well to integrate 1/10u. 1/10u. Yeah, get ln sin u. Okay. ln sine u. So do we use anything? We did use the how did I do button several times. It says, briefly explain in words how you would verify that the solutions you have are equivalent. You do not need to provide a mathematical proof, but write down the strategy that you would use. these two integrals were the same. Well, I know that ln sine u is equal to tan divided by sinus. Let's see. Ln x minus ln x squared plus 5 on 2 is equivalent to ln sine u, with u being with x over root 5 being tan u. Well, immediately I would utilize the fact that x is equal to root 5 tan u, and then I would put that in here, so ln root 5 tan u minus ln root 5 tan u plus 5 on 2 is equal to ln, sorry, this is squared, right? ln 5 tan squared u plus 5 on 2 of ln root 5 tan u. Hello.
Can I use your scale?
Yeah.
Is it in the bathroom? Shit.
Okay. If it's like ln minus a half times ln b, it'll be ln a over b would be like times a half of b. Like b on 2 is equal to ln 2a on b. I don't know, we should try. Hey, if it's ln a minus a half of ln b, would it be ln of a over b over 2? And then that would simplify to ln 2a over b? Hi. Hello. Hello.
Why can't you be tall?
Why can't I be tall? Choi Woo Sik. Wow. GG's. I can't do that.
Surgery.
Jeez. Unlucky.
Actually, 180 is not that hard.
Maybe. Kéo
You
chân.
should have tried.
Maybe kéo chân.
How tall are you now?
Like mét 73 đi.
70.
73.
I don't trust. So you and
Bill?
yeah,
Yeah, same height.
where?
You want the photo? I can ask Jada.
Oh no, it's okay.
Don't worry. Jada does not bite. 5 times tan squared plus 1 is ln root 5 tan u
Like saying this made me
minus
kind of overthink.
ln. No, why are you scared? I can ask
I'll
Jada.
call you back.
I can ask Jada.
I'm not scared.
Oh, okay. Then I'll ask, okay?
Why you think like that?
Because you said, oh, okay. Đừng hỏi. Don't worry. Giống người nhà hết.
I'm not worried.
Jada likes you, but you have to be open too. Jada was asking for a double date. And said, okay, I'm gonna ask Christine. Are you gonna say yes?
When?
After exams.
I don't know.
Why not?
I don't know what to do.
Hang out.
Oh, I'm all day. Bye-bye.
Okay.
Trong anh phải anh call bởi vì tao còn có 20%.
No.
Hi.
No. Don't.
No, I have to.
Don't be that way. Fall apart twice a day. I just wish. Trời ơi, chị hai ơi. Sao chị hai về nhanh thế? Xin chị. Để sai. Sign.
Thôi, bye-bye.
No, please don't. Please don't.
What? Nhưng mà mày học thôi, tao làm gì, tao quên lắm.
Please?
No.
No, please.
You're not gonna do anything except studying. I don't. Why do I have to stay?
Please? Using the substitute. Sorry, I'm gonna mute, but I do want you to call me just because So it would seem like finding another point. Why is that 8 equal to something? Tangent plane of the point passes through the origin. I don't know. Set XYZ to 0 and solve? If I have an equation of the tangent plane. I don't know actually. Intuitively. Intuitively, what am I looking for? If I'm given an equation of a tangent plane, what should I be thinking of with tangent planes? I know that we've grown from tangent lines, which are 2D spaces, to tangent planes, which is a plane that passes through a specific point of a surface. But then I want another one that passes through that a certain point. Would I be substituting zeros somewhere? Would I be differentiating something? Intuitively, what should I be doing? Surface is tilted. Suppose that the tangent line suppose that the surface is given by that, and there be another point Q. We want point Q, and the tangent plane is that. Okay. Solve this equation for A and B. Oh yeah. A plane that is perpendicular. No. I'm gonna need some type of plane that passes through. I don't even know how to think about this. You should just tell me it, bro. let another point be AB squared, and the tangent plane is that. Okay, they're giving us the way that we would solve it. We have the surface, we have the points, and then we're trying to find Q. T. Want to find Q is some x, some y, and some fxy. Sorry, let's do AB. Fx is equal to 2x. Fy is equal to 2y. Fxy is x squared plus y squared plus 4. Then let then find the tangent plane is equal to z plus, why is it minus? Sorry. Z is equal to z0 plus fx ab a squared plus b squared plus 4 times change in x, which is x minus a. Z is equal to a squared plus b squared plus 4 plus 2 of a times x minus a plus, right, so this is delta x, this is x, this is partial derivative of x at a times 2 of b times y minus b, right? Then set x, y, z equals 0 to find a, b. 0 is equal to a squared plus b squared plus 4 plus 2 times a times minus a plus 2b minus b. Minus 2a squared minus 2a minus 2a squared minus 2b squared plus a squared plus b squared plus 4 is equal to minus a squared minus b squared plus 4 is 0. We're going to bring that outside. Okay, solve. Oh my god, it's the opposite ones. Square root 2 minus square root 2, 8. I didn't think about it like that. Since you get like okay, now that we're speaking intuitively, that just means that because we have a function that has our x values and y values as squared, we could swap the signs and we'd have a completely, it's not completely different point, but we have the same point mirrored and it will still satisfy the equation, right? Exactly, because the surface is... The changing sign does not change, so from... You would obtain different mirrored points. There are different points in space, but all lie in the same paraboloid. You could also get root 2 8 minus root 2 minus root 2 8. You could also get 208 0 2 8 0 minus 2 8. Is that right? All of these work. All work. Right. This one we could see immediately is 9, which is a question we've done before, which is why, like, the moment you do a question, you will know how to do it. All right, let's continue. Consider the infinite series. Sum n is 1 to infinity of n factorial over 3 to the n times n to the n. Well, this one's going to be a strong-ass function, right? You would need to remember that x to the n is smaller than n to the n, which is smaller than n to the n. Right? I think Mr. Milan has this. Parfrac, differential equations, sequences and series, Maclaurin series, Taylor series. He's great. Sequences. E to the n is weaker than n factorial. I want you to come up with a list of various sequences for large n. So I want to see the relative strength. You know how, like, we have ln of n is always gonna be smaller than any n to the c for positive c, which is always going to be less than n squared is less than. Then I want to see stuff like ax to the n is less than e to the n, and that's less than n factorial, which is less than n to the n, which is probably less than like I give me like a super wide variety of tables of that sequence, you know, so I can basically just like look at it for a while and gauge and intuitively feel which one is stronger than which. Or we could use the ratio test, you know, normally, but like that's no fun. Right? X to the n is less than or equal to e to the n is less than or equal to n factorial is less than or equal to, or is way less than n to the n at large n. But yes, we'll use the ratio test. Man, stupid shit. We'll do a n plus 1 is equal to n plus 1 factorial over 3n plus 1 times n plus 1. A n is n factorial over 3n n to the n. And if we divide it, do they want... Yeah, they probably want us to... Do they want me to... I'm assuming they won't accept that this function. I don't know. 3 to the n plus 1 times n to the n plus 1. Firstly, we'll just keep that there. Another one. Yep. Divided by... Ooh, see that? Missed out on something. This one. N to the n plus 1. That looks so much worse. That looks so much worse. You guys see this? So we'll just compute it by hand. Well, I'm going to split this. I'm also going to split this. And I'm going to flip this so that we can cancel out some stuff. We get n plus 1 over 3n. Okay. Then what are we looking at? Taking the limit. Well, if you take the limit there, we see that is going to go to a third. This implies that the series converges. Why does it converge? Let's just do a third first. Wow, I got it wrong. A n plus 1. Oh, I forgot the n plus 1. Oh my god, Jaden. Then we have n plus 1 times n factorial over 3 times 3 to the n times n plus 1 times n plus 1 to the n times 3 to the n to the n n to the n, n factorial. We are left with n to the n over 3n plus 1 to the n. Right, and n plus 1 to the n is always going to be bigger than n to the n at large n. It's like you have 100 million to the 100th million and 101 million to the 101 million. So it's always going to be so much bigger. I mean, it's not so much bigger, but it's bigger. This is going to be n to the n to the n over 3 times open bracket n plus 1 to the open bracket n plus 1. Yes. And then we'll pluck it into ChatGPT. I mean, we'll pluck it into Maple. We'll have limit of that n to infinity. 0. Wow, I'm getting cooked. I'm getting cooked right now. 3 to n plus 1. See what I got wrong. Let's see. N plus 1 to the n plus 1 to the n, not to the n plus 1. Just to the n. This is to the end. Boom. This is exponent minus 1 over 3. So 1 to the... Sorry, this is... n to the n over 3 n plus 1 to the n. This is 1 over 3e. Why is this that the series converges? For huge numbers, 1 to the 3e infinitely goes to 0, no? Converges. I've never seen a limit take this form. Wait, the ratio test is what? The ratio test is if an plus 1 over an less than 1 converges. If an plus 1 is test fails. An plus 1 over an larger than 1 diverges. Right? Intuitively, you see that the next term here is going to always be smaller than this previous term, which is why the series will, like, it will end somewhere, whereas this one, it will be always larger, so you'd be adding something else. This one, it's hard. We could go to Maple and we can just make sure that we are getting this. We'll just do like 10,000, 100,000. 100,000 to the 100,000 times 100,000 to the 100,000. And we're gonna eval. And if it's like a small number, we kind of are given something. Okay. Hence, explaining short sentence why series converges. By the ratio test, a n plus 1 over a n. If for large n, if is less than 1, then the series converges. This is true since I don't know. Furthermore, I don't know what else to say. For the ratio test, if a n plus 1 over a n is less than 1, then the series will converge, because the a n plus 1 term is smaller than the a n term, which suggests that the next term is smaller and it will converge. But like, is that a satisfactory answer to the essay box that they have provided? What else am I to write just to answer this? I feel dehydrated. So you're saying that the key is the limiting ratio, right? So the ratio 1 over 3e is the thing that I should be focusing on instead of talking about the specific sequence or the specific term that's smaller, right? Understand. So the ratio, when I take it to infinity, is a very, very small number that's strictly less than 1. L, sorry, limit n to infinity of an plus 1 over an is equal to 1 over 3e is L is equal to 1 over 3e. This term 1 over 3e, where e is 2.71, is strictly less than 1. So the term, the series, will can converge absolutely. I have to use the key term here, the limiting ratio. Let's eval 1.0.122626 is less than 1. So the terms decrease as quickly. So by the ratio test, it will converge. Is there a satisfactory answer in the notes section? Calculus 1231 notes. Limiting ratio. R, they use R. R is less than 1, then the series converges. R is more than 1, then the series diverges. Behaves like the reason is that the ratio works with a Kármán ratio R. Ah, that's what it means. When R is more than 1, is divergent. So we'll use R. The ratio test, when taking the limit of n to infinity of an plus 1 over an, equals R, we have that the test gives us a ratio geometrically to see how the terms are either growing or decreasing. Since R is equal to 1 over 3e, this is strictly less than 1, and it shows that the series will converge absolutely. So behaves like AR in a geometric series, e.g. A1R is 2 a half R is a half. R is 2. This will be 2, 4, 6, 8. Sorry, 8, 16. Infinity. This will be I don't know, 216 maybe? Explain in words why limit of an is equal to 0 for an. So for the series, it's this. So this is 1 over 3e is is r, the ratio. Whereas this one is an, which is limit n to infinity of what? 3. Okay, so probably sign analysis that we're supposed to do here. Or at least fundamental analysis. So analysis of terms and them growing or not. So we want to be looking at the limit of n factorial over 3n to the n. Okay. What could we use? What's our toolkit? Well, we know that n is less than n to the n for large n. So denominator is larger. And the function decays. The n disappears. For large n. Could we say something like that? That's my assumption of how we would be answering calculus questions. Hello? So my reasoning is n factorial is a much smaller and weaker function than n to the n for large n. And so when you have this and you take it to infinity, you take n to infinity, the denominator is much larger and the numerator just disappears. Is that a satisfactory answer, or is there any specific way that it would secure me the marks? They say explain in words why the limit of n to infinity of an is equal to 0. And I have given you the question before what the limit was. What the nth term is, which is n factorial over 3 to the n times n to the n. So the quantity of 3 to the n times n to the n is the denominator. want my chips. I want chips so bad. Your intuition is correct, but the question says using A. Using A. Using part A. Wow. Calculus is tough. Now I'm not understanding why they would do that. Like why would they? Because the series converges, the limit also is equal to 0. Two different things. Woo! Series of an converges. Also, limit as n to infinity of an is 0. Wait, is this a universal thing? Like specifically that if I take a series to infinity and the series converges, that the anth the term an itself, the limit of that an is equal to 0 all the time? Why are they fucking creating an image? Series, infinite series. If the series converges, then lim converges. Then lim is 0. Convergent infinite series. Convergent infinite. No way. So this gives rise to the if limit of an is not equal to 0, then the series diverges. Oh my god. So is this a theorem that I should know? What? Oh shit. But if limit as n to infinity of an is equal to 0, this doesn't mean the infinite series converges. Limit as n goes to infinity of 1 over k is 1 over n is 0, right? But the infinite series diverges. Wait, just to be clear, if the limit of a term is not equal to 0 or does not exist, then the series will diverge. If the series converges, then the limit is 0. Limit of the specific term is 0. But if the limit of the term goes to 0, it's still inconclusive. We may not know that the term converges or diverges, even if we know that the limit is equal to 0, right? So it is a one-way statement. No, don't give me an image. What the fuck? Okay, I get it. Okay. Oh, baby. This is a one-way statement. If the series converges, if the series converges, then the terms must go to 0. If the terms do not go to 0, then the series must diverge. But if the terms do go to 0, that does not tell you anything. Fundamentally, is that everything that I need to know? The tests are just fluff. Fundamentally, is this what I need to know? Is there anything else I need to know? Not specifically about the test, but about this. Partial sums. Did we learn about partial sums that much? Sn is the sum of the series. AK. So K is the kth term. Oh, Jesus Christ. A sequence, AN. Just remember, SN is different from AN. Sequence. Very, very precise. It's increasing if AN is less than AN plus 1. Yep. So this is the anth term, an nth plus 1 term. It's non-decreasing if it's less than or equal to. It's decreasing if the nth term is larger than the next term, and it's non-increasing if, yep. If any of these properties hold, then the sequence is monotonic. Okay, I do not need to learn about suprema and infima. Infinite series. Any Sn is the, if Sn denotes the sum of the first n terms. Okay. Then we have Sn is a sequence. Don't fuck around. If Sn denotes the sum of the first n terms in the series, then that is a sequence. Thus, questions concerning the meaning of infinite series can be reduced to limited behavior of the set of series. Depends on limiting properties of the sequence of the set of kth terms. Taylor's theorem. Taylor polynomials, Taylor series. These are what? Second order, first order DEs. Okay. Let's make sure we have this right. A sequence is a function. Fn is a sequence. Subscript notation. This is a set of sequences. The an is the nth term of the sequence. Okay, the nth term of a sequence, because this is a set. The sequence is described by a rule an. Okay, the Fibonacci sequence is given by that. Suppose that the set or the nth term of a sequence. I mean, what do you mean? Suppose that that is a sequence. That is a the set containing a sequence, or the an. Ow, ow. The set of sequences of an. A subscript n. If the nth term of the sequence, right? If the nth term of the sequence, if the nth term of the sequence approaches some finite number L, then we say that the sequence is convergent. Okay. In my head, I'm like, okay, if the nth term converges to some L, approaches a limit, then in my head, I'm thinking like 1, 2, 3, 4, 5, 6, 7, then it stops at 7. So the sequence is convergent. If the sequence is not convergent, we say that the sequence is divergent. And the sequence is divergent if our nth term goes to infinity as n goes to infinity, right? So instead of going to 7, it goes to 1, 2, 3, 4. It goes to infinity. So the sequence goes to infinity. The sequence is divergent, right? Because there's no stopping point. Right? Same with the nth term going to negative infinity. If a to the n has no limit, but remains bounded, we say it's boundedly divergent. And if the nth term exhibits none of the behaviors, then it's unboundedly divergent. All right. So this term, in your head, you're like, okay, well, if I grow this number as big as possible, this nth term is going to go to infinity. This sine n to the half term is never going to go to infinity because it's bounded. It's always going to be between 1 and it's always going to be like this, right? As this is n goes to infinity. So n goes to infinity. It's always just going to be like that. If we zoom out, it's always going to be 1 and 1, 1 and 1, 1 and minus 1. Okay. 3n to the, so that's the nth term. If the nth term, that nth term goes to 3, right? That nth term goes to 3. So the sequence converges because the nth term goes to 3. If we have 3 over how much? 9 plus 4 times 3 is 12 plus 3 is 20. It's like 3 over 20 something. Then the next term is it's like a 0 point something grows to 1, grows to 2, grows to 3, stops at 3, right? As large n grows. That sequence is convergent. Once again, a to the n is the nth term. Minus 1 to the n of 2n. That is going to grow massively in both directions. Yep, that's going to grow infinitely in both directions. It's not bounded. They approach infinity. We conclude that the sequence is unboundedly divergent. Okay, I get that. Suppose that the sequence is a sequence of real numbers. The set of nth term of an given by a certain rule is a sequence of numbers, and we write that the limit of an is equal to L. Okay? We have some techniques for sequences. Limits. Okay, so when we calculate sequences, when calculating limits of sequences, when deciding if a sequence a to the n, look at the behavior of the nth term given by a to the n. So limit to infinity of a to the n. If a limit is equal to some finite real number, converging sequence. If limit unbounded divergent sequence. And then we have some limit rules of sequences which we could use, which we know. It's basically operations for limits, which is fine. Right? We're just stepping into whatever and we're looking at it. Yeah, we're just calculating said limit. We can use L'Hopital, so it's calculating limits of sequence. Alright. Alright. So the limit here converges to E, and the sequence will also be convergent. And we would not know what the sequence converges to, but we know that the nth term of the sequence would converge to E. Okay, I should remember that. Limit of 1 over, yeah, I've seen that in class before. Yeah, well, it's basically 1 plus 1 over 2 plus 1 over 3 plus whatever. We've seen that somewhere, at least. The set of sequences AN, set of sequences A, BN, and set of sequences CN are sequences. And for that sum project N, such that the nth term of the first sequence and the nth term of the second sequence and the nth term of the third sequences are small or equal to each other. Then if the limit of this one and this one is L, then this nth term is also equal to L. Okay, pinching theorem. Okay. 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 Skip infinite series. Divergence of sequences. The term in the above series are sequences. Instead of the plus, it's commas. If SN denotes the sum, then it's going to be the addition. But you could say that this is a bunch of sequences. These are a bunch of terms in a sequence. So the infinite series can be reduced to studying the limiting behavior of the sequence. Since the series the sum, if the sum of an nth term converges, then an, but right. Okay. Hard. Mathematics. This means it's eventually larger, you know? Since the series of infinite series of a n converges, the nth term an must be equal to 0. The limit as n goes to infinity of the nth term an must be equal to 0. Hence, explain where there exists some m larger than 0 with the property that will have n is larger than m, then I mean that just means that at large m there's a finite number m where our nth term, our 3 over n to the n, is going to be larger than 100 n factorial. So eventually the nth term will need to converge, will need to go to 0. Even with, so we'll say like, even with 100 n in the numerator, at large n there will exist a finite number m larger than 0, such that if n is larger than m, that our function, that our denominator will be eventually large enough and larger than 100 n factorial. This is due to the growth rate of 3n times n to the n, which is much larger than any n factorial. How do we explain that in good terms? They've had this one. Growth rate is rapid. Is there a table? What does this say? Is there anything else that's unrelated to growth rate, or would you like to make changes to my answer? The only reason that I would kind of understand that is that the growth rate of n to the n is just so much larger than 100 n factorial, you know, so that eventually at sufficiently large n, because we're taking the limit of n to infinity, we'll have that n to the n is just going to overpower 100 n factorial. Is there anything else? I don't know. Is there? Hence means they want you to use part B. Choose a threshold. Oh yeah, okay, so they want me to so it's limits of play. Okay, yeah. So they're asking for the definition of a limit, right? So I would be choosing I let epsilon be larger than 1, larger than 0, right? And then I know the limit goes to 0, and then we're going to try to solve for m. Wait, would I be choosing epsilon or m? Oh yeah. I would be choosing. I wouldn't be choosing epsilon. I'd be choosing m, right? But I'd set up an inequality for epsilon. Let epsilon be larger than 0. Then let m be larger than 0. Then by the formal definition of a limit, we want a n minus l, so l is 0. Sorry, limit as n to infinity of a n is equal to 0. Then a n minus 0 is equal to epsilon. And we have a n is equal to n factorial over 3n n n. Yeah. So given, okay. Given 3n n larger than 100 n factorial, this implies that one over 3n to the n factorial is less than 1 over 100 n factorial, which implies that n over n is less than 100. Therefore, choose m is epsilon 1 over 100. Then n factorial over 3n to the n is less than Oh yeah, this is the weird thing with limits. So this is all like scrap work, basically. Very circular, but scrap work. Okay, choose. Epsilon is 1 over 100. Let n let there exist in M such that an minus L is equal to epsilon, which is equal to n 3n is less than 1 over 100. As n goes to infinity, n, right? Take out absolute value. N is positive. N factorial over 3n times n is less than epsilon. So wait, so I'll do the scrap work, find the epsilon, then I start my explanation with proof of the proving or choosing epsilon is 1 over 100, and then using the formal definition of a limit. And if I have the formal definition of a limit, then do I write let epsilon be larger than 0, then choose epsilon is 1 over 100, then let m be larger than 0 with the property that n is larger than m, such that the nth term minus our limit, which is 0, is less than 1 over 100. And I'm going to rearrange and then make sure that 3 to the n times n to the n is larger than 100 n factorial. But we have to choose the 1 over 100 to make sure that that by the formal definition of a limit, it works. And we find the limit, and that's scrap work. But the formal definition of limit looks like that. Circular as hell, but then, okay. Choose. Do you remember how to solve choose epsilon is a, therefore, by definition of limit, there exists some n larger than m such that a n minus 0 is less than 1 over 100. Yep, makes total sense to me. Then a n is less than 100 implies that a n for large n, a n is less than or equal to 100, then n factorial over 3 n to the n is less than 100, then we'll just flip shit over. Yep. And 3. Boom. As required. Yes. Yes. Proof. Consider the differential equation that looks like a... Do you think it's exact? It's not exact. Okay. Well, we divide both sides and we get that. And then we consider that. And we consider this. Okay. Consider... Oh, do I need to do it twice? For a differential equation to be exact, the partial derivative, let what fucking let f y equals m and gx, sorry, yes, f y equals fx equals m and gy equals n, then
my, then it must be, and here, and that
that
y is equal nx. Then f of x is given by, then m is given by f of x is given by
so we have to partially different, yeah, here, right? So they have given us this. So partial derivative of f with respect to x is equal to 5x to the 20x cubed y 7th plus 3x, and n is equal to gy partial derivative is equal to 30 x fifth to the y fifth. Then mx is equal to my is equal to 140 x cubed y 6, and nx is equal to 150 x to the 4th and y 5th, which is not equal. It is given that the differential equation will become exact if both sides are multiplied by xn for some integer n. How do we used to do that? Exact differential equations. I'm gonna read my answer to you and you can see if it's sufficient or not. But what I wrote is that for a differential equation to be exact, we let the partial derivative of f with respect to x be denoted as m, and the partial derivative of g with respect to y is n, and that the partial derivative of m with respect to y is equal to the partial derivative of n with respect to x. Then m, which is equal to the partial derivative of x, is 20x cubed y to the 7th plus 3, and n is equal to the partial derivative of g with respect to y, which is equal to 30x to the
sorry, yeah, 30x to the 5 to the 5th times y to the 5th. And then when I computed the mixed derivatives, which is my, that's 140x cubed times y to the 6th, which is not equal to nx, which is 150x fourth times y to the 5th. Is that enough? Wait, wasn't it that the terms itself needed to already be partially differentiated and they actually didn't partially differentiate it? Like, why is it a function of two variables, f, and that specific term is not partially differentiated? Explain to me why. Because I thought that those terms needed to be differentiated first and then partially, sorry, they need to be partially differentiated another time. Yeah, so I thought the terms, like the mixed partial derivatives, needed to match. So would you already treat 5x to the 4 y to the 7th plus 3x as an already partially differentiated function from another function? So f might be h of x and g might be h of y, right? Should I write that at the start? Yeah, I know that. If the differential, yeah, okay. See, now it's better. Now they give me good reasoning. For a differential equation to be exact, consider a potential function h such that h with respect to hx is equal to f, and that's so much better. And h of y is equal to g. Then the exactness is if h of xy is equal to f of y is equal to g of x, which is equal to h of y of x, or the partial derivatives the mixed partial derivatives must be equal. Okay, beautiful. Sorry. Boom. Then f of y is equal to 35x for y6, and g of x is equal to 25 x squared, x to the 5th, y to the 6th. Therefore, not equal and not exact. How do we... I don't know if I was taught this, but I'm assuming there would be a skill to, not by inspection, that we could use to manipulate it so that the partial derivatives would be the same? Or is it here that we would multiply both by a certain number? Yeah, I don't remember. Do we... Pretty sure we integrate, right? We integrate by something. I don't remember. Làm chó thì nhớ được, đâu thì nhớ được, khó vãi cả bìu. Integration techniques, the chain rule, partial derivatives, the dependency table, the chain rule. Integrating factor.
So the method is my minus nx over n, and then find the term, and then use the integrating factor. Find the integrating factor using e to the integral of said term. Is that something that I learned? Làm cái chó thì nhớ được vài liền để kiếm lecture của thầy. Wait, do we have our grades for the Mobius is 10. We don't have a pre-exam total yet. Soon though. Soon. But we have at least 40, which is nice. Yeah. Làm sao mà nhớ được đây thầy ơi? Pre-recorded calculus, specifically the first order differential equations. This week I have to kind of do again.
So
integrating factor. Spam finding integrating factor. Exact differential equations.
Plus red.
Oh, he only taught us how to find the by partially integrating you can get the
Look, doesn't really. To y, so it is 3y plus y squared. Therefore, this is not. This is, we'll see that, have a look at what happens to the differential equation. So here's the differential equation. I'm going to multiply everything throughout by x squared. I'll get 3x squared y.
So, final question of this lecture. Note that you will not need to find your own integrating factors. Guess you do. Guess you do now. What the fuck? Okay. Stupid. Okay. So now we have to find our own integrating factors. Even though we were like forced to our own integrating factor. Use my minus nx over n. To find mu x. Okay. Sorry. My is, tell me, sorry. Gx on G. For marker, how else would we solve this? Desolve? So this is a skill, right? To find the integrating factor. Is that the formula that I should remember to be able to find the kind of the difference, and then I'll integrate that mu x to get the integrating factor? Is there another method? How did you intuitively come up with my minus gx over n? I want my chips, bro. I get my chips tomorrow. Okay, so this is how they think of it. Partial derivative of y times some mu x times m is equal to partial derivative of x times mu x times n, or f and g. Then since mu is a function of x, this disappears. Oh no, this so conveniently finding some mu x to multiply so that they align. So basically equate. Solve for mu x. On the, sorry, is a function of x, treat mu x on left hand side as a constant, right? So mu times f y is equal to, by product rule, right? Mu gx plus mu prime g. Yep. Then factor mu. So mu times fy minus mu gx is equal to mu prime g, which implies mu fy minus g of x is equal to mu prime g. Isolate mu. Oh my god. Recognize this is f prime over f is equal to ln x. Sorry, the derivative of mu x so mu, so find left hand side, then integrate e to the, to find integrating factor. What a pain in the ass. Is there a better way? Or did they want us to test like x1, x2, x3? In God's glorious, you know, like that would stump me up so hard, because I would not know what to do. You know, if they said, "Oh, find n," like, bro, GG's. So you've got f of y is 35 x to the 4, y to the 6 minus g of x, which is equal to 25x to the 5th y to the 6 all over g, which is 5x to the 5 y to the 6. Right. I could do 5 x to the 4 y to the 6 minus 25 x to the 4 y to the 6 times x. Let's just make it a little bit nicer to see. And 5 x to the 5 6. We could do this. Seven. Oh my god. 7 over x minus 5 over 1. 7 minus 5 x over x. Huh? Show me how you got 2 over x. Wait. What happened? 25x to the 4? G of x is 25x to the 4. Okay, fine. See, well, that's so much easier. 7 over x minus 2. 5 over x is 7. 5 over x is 2 over x. Integrating e to the 2 over x dx is equal to, well, 2 e to the 2 ln x
is e to the ln x squared is x squared. And that gave us n, x squared. So n is 2. If I don't know, D solve, open bracket, sorry, what's our answer? Okay. Is now equal to then D solve. What do we have? D solve is what? No initial conditions. Right? They want me to find the general solution. Could I solve it with maple? I could. How about I just remember how Milan Pahor taught me how to do it?
So coefficient Dukes by the underlying function yourself figure out for you. Just call D. With respect to Z to the 2y.
Wait, we integrate our answer? Okay. Then f of y is 35x6y6 is equal, n of x is equal 35x6y6. Then how do we do it?
integrate, partially integrate. Fuck. I wish I remembered. No, with respect to what? It's just a bunch of numbers to me. We studied cosine. Trig subs. Parfact bullshit. Salt shit. First order exact, motherfuckers. Now watch carefully. Check for exact partially integrate m and n with respect to partially integrate m and n f and g. Oh, okay. Since f is equal to some hx and g is equal to some hy, we're going to integrate f with respect to dx and integrate g with respect to dy. So we have integral of 5x to the 6y to the 7 plus 3x cubed. We have 5x7y6 dy. Then the integral of f dx is equal to the integral of, I don't know, pull the 5 out. Sorry, pull the 5y to the 7th out times x to the 7 on 7 plus 3 times x to the 4 on 4 plus some constant c of y. So 5 on 7 x7 y7 plus 3 on 4 x4 plus cy. And the integral of g dy is equal to, well, you pull out 5x to the 7th, right? You have y to the 7th on 7. So these two are the same, plus some d of x. So that's that. So general 5x y7 plus 3/4 x fourths. Ugh. 5x7 times y7. Oh, I forgot the over 7. 5 on 7 plus 3 on 4 times x to the 4th. Wow. That was a total pain in the butt. That was a total pain in the butt. Holy shit, that was a total pain in the butt. McLaurin series. Ow. That would have hurt people's. That's better. Okay.
Equals.
Okay, 2. Boom. The population of two competing species vary over time according to the system of differential equations. Ooh. Milan Pahor. Assume that x of t and y of t have these Maclaurin series. By implementing the initial conditions, determine the values for b0 and b1. Right. So integrate 3 of x dt. Three xt plus c. Then y0 is 0 is 3x0 plus c, which implies that c is equal to 0. No! I don't care the function. dy over dt is the same as b1 t. Maclaurin is x at a at 0. So b0 is, I guess we do need it. We needed y of 0. No, that's 0. b1 dy over dt of dy over dt at t is 0, which is 3x. I think that's how we do it. 3x here and 0 here. What? 3? Think. DYT is 3x. DYT at 0 is 3 of x still. Okay, here's a new question. B of 0 is the first coefficient of the Maclaurin series, right? Which is like y evaluated at 0, which is given as 0. And then dy over dt, so y prime, right, first derivative, is 3 of x. So I would assume that at t equals a equals 0, would it also be Would it also be 0? What the fuck? That's so dumb. I don't know how you're supposed to be looking at this from a different perspective. Dude, what the fuck? You could never. You could never convince me that math is not made up. Yeah. Yeah. By substituting the two series into the differential equation in one, we have
an plus 1 why? Because you differentiate it is equal to bn. So they're saying this is dx so they call this a an bn, and an plus 1 is the same as d over dx or dt is equal to 3 times bn. Three n. Where do the n's come from? N plus 1, n plus 1. Okay. Pn plus 1 to infinity. I don't know. What the what are they asking, bro? It's just one of these questions, bro. What are they even asking, man? Tell me the answer to C of n. N plus 1.
Matching the coefficient of t to the n. Xt, x derivative of t is equal to 3 of y of t. Oh, okay. Okay. Hello guys. And from what I can see here, dx over dt is the same as x prime of t is the same as, if we cancel this out, we do ta1, we do a1 plus a2, 2at a2t plus until n a n t n minus 1 plus n plus 1 a n plus 1 t n. And since dx dt is equal to 3 of y of t, and this is equal to b No, I would want you to. Does that mean that the A1 and B1 kind of cancel? Is that what you're saying? Can you try to expand it and show me? Like, I do understand that the derivative of x, so x prime t, is with power law, you're bringing everything down. But when you say matching the coefficients of tn, I don't really understand what you're trying to say here. So show me fundamentally that x of t is a0 plus a1t, right? Plus a2t squared, and so on. And the derivative is, with power law, what you've done, up until the coefficient n plus 1 times a n plus 1 times t to the n. But y of t is b0 plus b1t and so on. So why is it ending at bn? Yeah. Power drops by 1. Okay, that's better to see. So the important part is this, right? By power rule, x of t is given as and oh, is also I'll write it like this. Okay, that I understand. Perfect. So B and yeah. Wait, really? For the Tn plus 1th term, yeah, what happens for the Tn plus 1th term? Is it 3 over n plus 2? Is that our Cn? Okay. What?
Dude, what? I wish I knew. Oh, I don't even know anymore. I wish I knew you wanted me. I wish I knew. Oh, 'cause it's A-N. It's some X, right? It's some X. YT is equal to B0 plus B1 T plus B2 T squared plus onwards, which is also equal to these recurrences are so gay. Well, what we see here is that this is equal to this. So y of t is b0 plus b1t plus what the B next one is also B0 plus 1 is equal to B0 C0 0. Dude, I wish I knew.
I don't know, man. What a weird recurrence. B2t squared. Dude, what the fuck? B2 is equal to 3 over 1 Bn plus 1 is equal to Cnan. Right. Bn plus 1 is equal to 3 over n plus 1 an. N 1, 2, 3. B2 is equal to 3 over 2 times A1. 3 over 2 of, what's A1? Hey, they're telling me to fill out some things. I have no clue what to do next. I think you should just teach it to me from the start. Because I have no clue what to do next. You now use the two recurrence formulas repeatedly to generate the coefficients. The Maclaurin coefficients begin with A0 is x0. I keep forgetting that each A is a x double prime at t. Oh my god. Oh my god. Oh my god.
Okay, let's think about this again. The next coefficient, you've got x of t is given by a0 plus a1t plus a2t squared plus so on to the a-nth t-nth plus, right? a-n plus 1 t-n plus 1. You've got y as, these are the coefficients. B, it's just derivative, plus derivative of y times t plus second derivative of y times t squared plus the bnth derivative and bnth plus 1th derivative. You've got x of t is equal to 3y of t. So, and y of t is 3x of t. And you've got x at 0 is minus 4, and y at 0 is 0. Then, figuring out a recurrence, that a n plus 1 is equal to 3 over n plus 1 b n. bn. And bn plus 1 is equal to the same thing, an. Then a0 is equal to x evaluated at 0, which is equal to minus 4. Right? b0 is y evaluated at 0, which is 0. Then b1 is y prime evaluated at 0, which is the same as 3 times 0 plus 1 sorry, yeah. Let's do this. b1 is equal to 3 over 1 a0, which is 3, which is the same as y, which is 3 times x evaluated at 0, which is 3 times minus 4, which is minus 12. Okay, b2 is 3 over 2 a1, which is equal to y double prime 0, 3 on 2 times x0, x prime 0, which is equal to 3y. 3y, isn't it? Three y0, which is 0. b3 is 3 over 3 of a2, which is y triple prime 0, which is 1 times a2, which is 1 times x double prime 0, which is where do we keep going from here? X prime 0 is B2, sorry, is C2 0? 0. Tell me I have the right answer. Let's go. C3. I mean, well, A2 is equal to 3 over n plus 1 of B1, which is A2 is equal to 3 on 2 of minus 12. So B3 is equal to 3 on 2 times minus 12. Minus 36 on 2 is minus 18. B4 is C4 is 3 on 4 times A3, which is A3 is equal to 3 on 3 of B2. And B2 is equal to 0. So this is equal to 0. What the fuck? Jesus Christ. Wow. What the hell? That's a weird question. Combining these into a single equation, we show that that is equal to that. By solving, express yt as a hyperbolic trigonometric function. Don't play with me now. Up to now, I've understood it, and I can solve it, combining them into one equation. Okay, think. If dy dt is equal to 3xt and dx dt is equal to 3yt, x equals, sorry, x evaluated at 0 is minus 4 and y evaluated. Mathematics is fucking scary. D solve. Open bracket. diff what does that mean? Does that mean that y prime of 0 is equal to 3x prime 3 of x, which is equal to minus 12. So I have this one and I have this one. I can solve y of t minus 9 y of t equals 0 with y 0 equals 0 dy 0 equals minus 12. Hyperbolic trig function. Let's see it. What a fucking paper. Who in their damn mind would solve this? D solve, open bracket, differential equation, yt, t with respect to 2, minus 9 times y of t is equal to 0, with y of 0 being 0, but d of y of 0 is minus 12. Sorry. That's the equation. And that's another open bracket outside. Boom. Sorry. That's outside. And then we're solving for what? Y of t. I wish I knew. I wish I knew you wanted me. I wish I knew. D solve. That's a hack, bro. Diff y t minus 9 yt is 0, y0 dy 0 yt. The answer is minus 4 shine 3t. Bro, what? If I had to do this question again, I don't know if I could. Sorry, I'm just being a little bit OCD here. But the goal is to have these guys out and just interchange them like a bunch of maniacs. You get A0, you get X0, you get Y0. You have more than enough things to build on top of each other and refer to so that you can find your way back. I just don't know if there's a better way to explain that, but
Yeah, you just keep moving. Every time you see something stuck, you refer to each side of the equation. So each side of the equation will take you back to a number that you could use. Like A2, you're stuck with A2, but if you could find a B1, you do know that A2 is something of B1, so then you use B1. And once again, B3 is something of A2. Right? So B3 is something of A2. If I was forced to find B4, sorry, let's find B5. Well, B5 is 3 over 5 of A4, which is equal to, well, A4 is 3 over 4 of B3. And B3 is minus 12 here. So we found our way back. Uh, 9 over 20 times minus 12. That gives you the answer. Let's find B6, eh? B6 is a half of A5, and A5 is 3/5 of B4, which is, well, B4 is 0, no? Yep. So this whole thing is 0. This is minus 1, I don't know. 45 times 100. Fucking 450 plus, sorry, minus 450 minus another 90 over 100 is minus 540 over 100 is minus 54. Jesus Christ. Yeah. I don't. Oh my god, this is another fucked question. Whatever. Another 8 marker. Another 8 marker. A question we've done before. Wow, these exams are a pain in the butt to do. Okay, we're 3 questions away from glory, but we have not watched the Comm1140 lecture. When do we watch it? Holy moly. Just to check, is B5 minus 54? Three-fifths times 27. Sorry. B3 is minus 18. Minus 18 right here. Okay, I got the recurrence down. 9 times minus 18 over 20 minus 81 over 100 is equal to 8.1. Alex is good. He posts every day. He's so fucking crazy. Oh my god, I forgot to drink supplements today. I'm gonna drink my supplements now.
Man, fuck that shit. I ain't doing all that. Cause I just got a dope ass new one. I just got a fucking new job. Oh, congrats to me. But there's a slight twist. I just quit my 9 to 5. I just quit my 9 to 5 job.
My bad, guys. My bad, guys.
Man, fuck that shit. I ain't doing all that. Cause I just got a dope ass new one. I just got a fucking new job. Oh, congrats.
Lock in. Next question. 2 bank accounts are opened simultaneously. We all call them account X and account Y. At the end of each year, the interest is paid to account X. Account Y starts with 250K and earns 6% interest per annum. At the end of each year, half the interest is paid into the account and half into account Y. Ooh, so vector question? Interest. Interesting. Algebra notes. Interest. Okay, DTs, and DTs. What are improper intervals again? So use first principles and derive interest-bearing formulas is what we are going to do. Account starts with 100K, 5 per annum. At the end, the interest is paid into account X. Half of the is paid into X and account Y. Let X and Y be the amount of money in dollars in X and Y at the end of n years, including the nth interest payment. Find a matrix A such that Vn plus 1 is equal to An for all non-negative integers n. How do we do that? Do not enter A equals. Oh, okay. So you create a matrix. So AVN is Vn plus 1. It's n plus 1, so x2, x3, x4. Let's start. We start with V0 being, do we want to do in dollars or hundreds of dollars? Let's do V0 is 100,000, 250,000, and then V1. Okay, think of the skills that you've learned. You're usually given a matrix and then you diagonalize it. But you'd multiply it by a 2-on-2 matrix, right? Your 1, you're gonna have fucking, I don't know, 100K. Let's just do this intuitively. Times that.
plus a half, okay, half of the interest of 250,000. And he has 250K times plus yeah, let's do this. X0, Y0, B1, X0 times 1.05. Yeah, so at the end of every year, at the end of the first year, he has the principal amount, right? And the interest amount plus a half of the interest amount of Y0. So X0 should be Y0 is, sorry, yeah, Y0 times 1, half of the interest is paid into the account. So 0.03. Yeah. Okay. That's it, eh? So maybe we suppose we try, well, that means that's right, 1.05x plus 0.03y and 1.03y. And then if we turn that into an equation, like a transformation, right? Now we have a couple of equations. You know what? We'll cheat a little bit by using our algebra notes. Such good notes. But you'd be looking at the linear transformations, eh? Oh, shit. One sec. Eigenvalues and vectors. TKO, 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 TK, probabilities, 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 permutations, combinations, grids, grids, grids. Where all my chips go? Just toss my chips everywhere.
3 eigenvalues and vectors. Find a basis. Okay. Transform it using the basis. I hope that's right. Oh shit, I'm goated. It's right. The hell? How do we obtain the above matrix? Let the vector be x0, y0. Then reading the question, I would create the vector of the next year. Vector v1 be equal to 1.05 times x0 plus 0.03 times y0 and 0.03 y0.
0. So this would be, so the first component would be the principal and the 5% interest from the previous year, from the money in the first year, plus with half of the interest, which is 3%, from the account Y, whereas the second component would only have the principal Y0 and the 3%, which is half of the interest paid into that account. Using that, we have a vector. Then to turn it into an n by n matrix, I saw how I investigated how 0, 1, how 1, 0, and 0, 1, which were my basis vectors, would look under this transformation for E1. T E1 equals 1.050, and T E2 is equal to 0.03, 1.03. The matrix will combine all of my basis vectors together in order so that I could get the matrix 1.05, 0, 0.03, 1.03. Find an invertible matrix and a diagonal matrix such that A is equal to MDM and DAB, where A is larger than B. Okay, okay, well, A is fortunately lambda is equal to 1.05 and lambda is equal to 1.03, which is nice because we basically a upper triangular matrix, right? Upper triangular matrix. So we have A is 1.05 and 1.03. Nicely done. Enter the matrix M below. Well, M is made up of the eigenvectors, right? M is eigenvector. For lambda is 1.05. The kernel of
fucking a minus 1.05 times I second is equal. We're just going to use maple for this. We're setting A as some matrix 1.050 0.03 and 1.03, right? And then we have DD as some 1.05. Sorry, 1.0. Oh shit, I just broke my leg. Sorry, baby. Sick, eh? McLaren. Okay, 1.05 0 0 1.03. All right, and then our M, what we could do is we'll do the kernel, which is with linear algebra, the kernel. No, we should just do null space, eh? Yeah, null space of a minus 1.05 times identity matrix 2. Okay, it does look like I have to solve this by myself. Minus 0.02, maybe? Is that right? Think. Maybe not null space. Maybe I just look at this. Right? We'll call this what? I don't know, A1. Fuck. We'll do it 0, 0, 0.3, 0.03, sorry, and negative 0.02. And then we'll have linear solve A1 and, sorry. Yeah. Linear solve A1, open bracket, 0, vector, 2.
0, 0. Why is there no space 0? They're totally independent. So the first set of vectors is 0, 0. Invertible matrix M. Fuck! Okay, well, 0, 0. I mean, sounds alright. For lambda is 1.03, kernel of A minus 1.03 times the identity matrix. Well, that's 0.02 here, 0.03 here, 0 here, 0 here. Alright, so we'll call this M1 and M1. Okay, and then we'll do M2 is 0 0.020, 0 0.03, and 0. And then linear solve M2. No, it's not. Sorry, M2. Minus 1.5. Okay, there you go. Found it. Minus 1.5. And 1. Does that mean that the matrix is not invertible? Span of then maybe we have M is that's a trivial solution. Think, are you right? Who fucking knows? God did 0, 0 minus a 1.5. 1. That looks so wrong to me. No. Wait, so it is. That means it's still diagonalizable. Fuck. I'm crying tears. Crying tears. No, it isn't. No, it did not say that. Tell me where it said that. It says, at the end of each year, the interest is paid directly into account X. So account X does not need to split any of the interest. Okay. Find me the eigen values for this matrix. Eigenvalues. Now associated eigenvectors and an invertible matrix M, consequently. This gives y is 0, with x being free. This gives y is 0 with x free. This gives y is 0 with x free. That's the only part where I'm like, it's like really weird. Free parameter. That's by far the most important part of today. Choose the free parameter, which means it's a span of any 1, 0. Therefore, we have matrix M is 1, 0 minus 1.51. This part 3. Since A is an upper triangular matrix, we read the eigenvalues across the diagonal. Then we get lambda 1 equals 1.05 and lambda 2 equals 1.03, of which lambda 1 is equal to A is larger than lambda 2 is equal to B. Then we find the null space for the kernel of the lambda, the associated lambda, to get the eigenvector. The null space of the characteristic equation with the substituted lambda to get the eigenvector. For lambda is equal to, for A is equal to 1.05, we get the matrix 0, 0, 0, 0.03 minus 0.02. So x is a free parameter, y is 0. We choose the associated eigenvector is 1, 0. Right. Try 0, 0, 0.03, 0.02. Zero, zero, and 'This is an eigenvector of matrix A because, which is also checked. Similar for B is 0.103. We get the, after subtracting from
characteristic polynomial equation, we get 0 0.02 0.030, and thus we get a null space minus 1.5 for any parameter. We combine these column vectors in order to get m is equal to 1, 0, minus 1.5, 1. Okay. After 9 years, the amount of money in dollars in the account is... The fuck is this question? It's a whole process. Well, okay. A is 1.05, 1.03, sorry, 0.03, 1.03, and 0. A n is given by m times dn times m inverse, which a n is, sorry, I'll just copy it again. M is equal to 1, 0 minus 1.5, 1. D is 1.05, 1.03. M inverse is maple. Then AN is equal to M times D, dn M inverse. With maple, we get... Okay, let's just set M is equal to... let's cut all this noise out. Okay, let's clear the table here. M is 1, 0, 0 minus 1.5 and 1. We'll start with MD is equal to... Sorry, yeah, MD is equal to matrix multiply M double D. Sorry, and we'll also do D to the N and this to the N. Then we have MDM inverse, which is matrix multiply of MD and matrix inverse of M, which gives us that nice little equation. Right. That gives me AN. Now, what is this? Sorry. Let's subs n equals, sorry, subs open bracket n equals 9 into MDM inverse. We get that. Okay. So we call this A9. Good? A9 is A to the... Could we do that? Nope. And then we have our principal, which is V, which is 100 grand and 250 grand. Is that right? Yep.
And then we have matrix multiply A9 times V. And that finishes us off. That means we can round, round up. I don't know. It's okay. We'll go back to here. Sorry, we'll go back to this one. And then the account, well, it says this is the money. 247,951 and 326,193. Is that correct? Nice. And this part is explaining it, which is fine. Let's go back here. We'll have AN is equal to, nah, it's okay. AN is equal to MDN M, which is equal to 1. Sorry, I'm trying to look at the number. 1. Jesus Christ, what are they trying to fucking tell me? Okay, 1.05 to the n. And there's 1.5 times 1.05 to the n minus 1.5 times 1.03 to the n, 1.03 to the n, and 0. Then V9 is equal to A9 times V0 is equal to 247,590.95, 326,193.296 is equal to 247,591 and 326,193 dollars. Right, we're good. Q9, is it? It's Q9. Okay, is there anything that I want to look at? Fuck. I'm tired, bro. I'm shattered. I'm shattered. Comm1140 final lecture. Should we watch it now or in like half an hour? I mean, I have class at 12. So I just need to be awake at 12. Right? Yeah. I don't even need to go to class at 12. I stay for the lecture at home. Should I go for it? Yeah. P is some polynomial degree 2, some integral x p dx. Whoa. Whoa. No, that looks like distributions. But it's row echelon form, dimensions, and bases. It is given that B is a subset of S. Consider the following maple session. You give me some R, which is an expression of 150x squared plus 81x minus 119, 29. Then you are going to integrate x times R from 0 to 1. And that gives you an area of 0. Okay. Then with linear algebra, you also have a set containing two polynomials, right? And now you're turning those polynomials into column vectors. When we reduce it, they are linearly independent. And explain why this is not in S. Well, we're going to augment it, do 150, 81, and 137, and then see if our guys can make it. No, sorry, it's not in S. S is a set of... Oh, it's this one. It's this one. Well, we just gotta integrate. I don't know. We integrate X. Integrate 0, 1 of X times 150 minus 137 dx. The integral of 100 and... Let's fuck up this integral right now. The integral of... Do you want me to int? I'm just gonna, it's too trivial. I'm gonna maple it. It's a pain in the ass to be doing so much math. Integrate open bracket 150x cubed plus 81x squared minus 137x with x ranging from 0 to 1. This is equal to minus 4, which is not equal to 0. Therefore, not in S. Okay? The maple code shows a matrix. Sorry. Okay. Once again, here you go. Integral is equal to 4, not 0, so it's not in S. The maple code shows a matrix A which has the columns made from the coefficients of the polynomials in B. The reduced row echelon form is shown to have the leading columns. Wait, it's been 9 hours. What have I done in 9 hours? You have watched 2 lectures, or 1 big lecture, and done 1 past paper. Is there anything else you've done? Not much. I'm slow at this. I'm very slow. It's okay. Fuck, what do you want me to write? I don't know, leading columns. Got pivots. Linear independence is I don't know, lambda 1 vector 1 plus lambda 2 vector 2 plus lambda 3 vector 3 plus lambda n vector n is only equal to 0 if dimension of S is 2. 2-dimensional. 2 pivot columns. Column space 3, but 2-dimensional. I don't know how else to say it. Explain why B is a basis for S. Is it? It's given that B is a subset of S. It is a basis for S. Why? Because when you integrate, you get I can read ChatGPT and it'll give some satisfactory answers. Okay. We're just gonna make sure we understand what it's trying to say and then move on because I do want to get to bed. Yep. These are writing questions. It's very abstract. I want my chips. Yeah, that's fine. The columns are the coefficient vectors of P1x and P2. Since the reduced relation has pivot in both columns, the coefficient vectors are linearly independent. Okay, that's fine. A general polynomial has 3 coefficients. One independent linear equation relating these. General polynomial has three coefficients, a, b, and c. Yep. But the condition that the integral of x times px gives one independent linear equation relating these three coefficients. I don't get that one. Oh, okay. That I understand. Okay, I should write that in. 2 for set B, what, like px1, sorry, p1x, p2x, ref shows linear independent. Sorry, we'll start with the definition of a basis. So basis is for a vector space is equal to set of linear independent vectors that span the vector space. So it's both spanning set and linearly independent set. Sorry, my bad. Independent set. Right? Also, dim s is 2. So dim s, so dim s is equal to number of linearly independent variables in vectors. So B's P1x and P2x also span the whole of S. Okay. For everything I do understand except question C, explaining why the dimension of S is equal to 2. Like from a polynomial perspective, you know? Like, yes, I do understand that there's 2 pivot columns. Even though the column space is 3, right? But there's a dimension space which is just 2. So how do we talk about that? I don't know how to say that. And I also don't really understand what you said about there's an independent linear equation relating the 3 coefficients. Oh, okay. So you integrate them. That's why. Like CX gets integrated to like 2, 0, and the whole thing needs to equal to 0 afterwards. So you're saying when we integrate them, there's one big equation, a over 4 plus b over 3 plus c over 2 needs to be equal to 0. And so we can create c with a and b. And so there's only two free there's only two restrictions. Yeah, so there's restrictions on A and B, and C becomes a free parameter. Could you say that? The integral, oh, it's right here. So if we integrate, let's say a right, and we have integral of is it p of x or f of x or any x? P of x. So in this case, the x doesn't matter, but the box given by like a4. Now let's just do it first.
Okay, that's fine. We'll continue. Let these be vectors in R4 to find the transformation well, linear map is a addition condition, and a times the vector x, b times the vector x, and c times the vector x. Wait, what? That's mad. Ew. This is like a vector inside of a vector. Or sorry, it's a dot product of the vectors, which is weird. Cool. Linear. Add and condition. Add means that t of x plus y is equal to t of done. Scalar multiple. Case of find the matrix A such that T of X is equal to sum A of X. Wow, very cool. So find the matrix A. Well, firstly, we have to have T of X. It's this big fat function. Oh my god, it's massive, guys. I mean, I want to ask if chat can do it, but it's gonna be, sorry. Do I want to write it like that?
first? I do. Yeah, I do. So you've got x1, x2, x3. One, one, minus one, two, minus two, two, one, one, two, minus two, one, minus 14. And then okay. x1 plus x2 minus x3 minus 2x4 2x1 plus x2 plus x3 plus 2x4 minus 2x1 plus x2 minus 7x3 minus 14x4. And then I think we could just like infer, fortunately, that we have this is a 4, sorry, this is a 3 by 4 matrix. So 3 rows, 4 columns. Which is what we've seen here. So we could do like 1, 1, minus 1, minus 2, 2, 1, 1, 2, minus 2, 1, minus 7, minus 14. Right. 3 rows, 4 columns. One, minus 1, minus 2, 2, 1, 1, 2, minus 2, minus 1. Oh, sorry. Where'd my shit go? I just tossed it out the window. Where'd my minus 7 and minus 14. Hope that's right. Yep, we're good. You know what? I'll just make sure it's green so that I'm happy. In the box below, explain in words how you can find the rank and nullity without using any computer application. using row operations. And finding pivot columns and row reducing until we get into row echelon. Then we can look at the amount of pivot columns and non-leading columns. The number of pivots signifies the rank, and the number of non-leading columns signifies the nullity. Perform the calculation on paper. No, I'm not gonna do it. For every, there exists such that, well, we'll have to check the nullity. But okay, we have the vector. Fortunately, sorry, we have the shit. Okay. Is there anything we can use here? Nope. Okay, I guess we could. Nah, it doesn't need to. We have, we'll do A is 1, 2, 1, 2, minus 2, 1, 1, 1, minus 1, 1, minus 7, minus 2, 2, and minus 14. Fuck. Okay. Right. Then we, with linear algebra, rank a null space a done 2 2 false for no, since nullity is not equal to 0, there are some vector oof. Yes, true. True. No. There are some vectors in R3 that are not in the image. So the domain of R4, there are going to be, for every vector in R3, there's going to be another vector such that y is equal to the transformation of that vector. No, because nullity is not equal to 0. So there are some vectors in R3 that are not in the image. So there wouldn't exist. So in all of R3, there. So the statement that for every vector y in R3 there would be a vector x as the input would be incorrect. I don't know. A fuck. Oh. Give me in normal writing, not in LaTeX. Wait, we're done. Oh. Oh. Oh, buddy, we're done. We're done, buddy. 2. False. Dim. 2. Rank. 2. R. Y is R3. And M. Dim of M is 2, which is less than 3, so it only creates a two-dimensional image space. So there are some y in R3 where there cannot be an x in R4 such that transformation of x is equal to y. Dim im 2. Dim im t is 2, and rank is 2. Give me this one. Row ops. I don't know what else to write. Row ops. REF. Pivot columns. Non-leading columns. What does chat say? Chat says, reduced to row echelon form, rank is number of pivot positions, nullity is numbers non-pivot columns, or free variables. So rank pivot positions or leading columns. Wait, GG's, I'm done. Hell yeah. Comm1140. This one is a question I've done before. Quit and save. Nice. What we will do is we will just sorry, we'll need this second screen. First screen. First screen. Main screen. We'll try to ram through the post lecture real quick. With some chat. Answer B for question 1. Yeah, I'm just a teenage dirtbag baby. I'm just a teenage dirtbag baby. Post lecture. Sick. Nice. Do you think I'll be live to maybe look at Comm1140? I've chosen Friday. I've chosen the furthest time out. I don't know why they are doing like those really far exams. 18 is like super close. Maybe because I have a
comm paper. I don't know. Because I would not have enough time to revise for anything. I would probably not get an HD if I don't study my ass off. Study my ass off. Comm1140. Also, I do want to look at some tutorial material, just 5 seconds, on week 9. See if we can watch the lecture material at 2x speed. Online lecture recordings for August 3rd. Where is it? On campus lecture recordings on Echo for the August 3rd lecture, which was 1 hour 30 minutes long. Let's spam this. Come on, give me some noise. I'm not deaf, ain't I? Where's the I cannot hear it, bro. Did she do the ultra mute button, bro? She's cooked. Let's see what they're looking at. Solutions for inspired practice hidden from students. This may not be downloading this version. It's wasting my hour, bro. Okay, let's just read the content.
Don't even want to call it a lecture. But understanding the link between corporate and social responsibility and financial management. Understanding the different forms and components of non-financial reporting. Broad concept that refers to social responsibility. Behave in a way that satisfies company stakeholders, employees, customers, and society. Sounds like Comm1140. Yep. CSR. Expectation, all organized. SDG goals. We're getting close to 2030, but don't think it will happen. How are companies encouraged to adopt stronger social environmental practices? Okay. Is there tutorial material? Except the shit that we're gonna do tomorrow. So this is common. Lecture materials. And the test your understandings are you know? That would be one of the harder ones in the test. Okay, but once again, okay. Nope. I think we're gonna go sleep now. Oh, sorry, Comm1140 tutorial material. Man, if I was able to go back in time and cook the first few papers, I would be able to get away with not needing to do this one. I have to do it. Sorry, this is week 8. Yeah. Week 8 or week 9? Week 9, eh? Week 9. Tax. Big one. Tax. Okay, tax. It's weird, eh? Test is this week. And next week, I don't know if there's a... But I hope not. When's the last day? Y units W.